Hello students, welcome to the class. So in our series of crash course, today we will study organic compounds containing nitrogen. So this is our day 35 of 40 days crash course. This is our disclaimer. Now in today's class, we will first of all cover the chemical properties of nitrogen. In the previous class, we studied about the preparation of the organic compound containing nitrogen. In today's class, we will learn about its chemical properties, including its reactions and basicity, and then we will move on to the basic nature of amines, which is a part of your chemical properties. After getting that, then we will move on to acylation. So this reaction you are seeing right now is a example of reaction involving aromatic amines, that is your aniline and its derivatives. Then after we will move on to carbylamine reaction, which is a test used for the identification of primary amines. After that, we will look upon the reaction of organic compound containing nitrogen with nitrous acid. So amines can show different reaction specifically depending upon the type of amines that you are choosing. It gives a different reaction for primary, then a different one for secondary, and a different one for tertiary. So depending upon the degree of amine, you will get different reactions with nitrous acid. Lastly, we will see the electrophilic substitution reaction, which is again a part of aromatic amines, which is your aniline and its derivative. So you have learnt about this electrophilic aromatic substitution in the previous classes also. It is basically the substitution of hydrogen with a electrophile. Now here electrophiles are of different types depending upon the reagent which you are taking. Suppose we have nitrating mixture. For nitration means introducing NO2. Then we have acylation and alkylation of Riedel-Crafts, in which we introduce an alkyl group or a acyl group. Then we can also have halogenation, in which we introduce different kinds of halogens into the ring. So all of them goes through a similar type of mechanism. Only the part that varies in all of this is the generation of an electrophile. So it will be dependent upon the reagents that you are taking. Later on, the remaining parts of your reaction are quite same. There will be formation of sigma complex, and then there will be restoration of aromaticity. So with this, let us first move on to the chemical properties of amines. Amines are reactive and behave as nucleophile due to the presence of one unshared pair of electron. We have seen the structure of your amines, and you know it's a derivative of ammonia, so it will have a lone pair similar to the case of your ammonia, and this is the reason they act as a Lewis base. Now the reactivity is decided by the lone pair and how easily the lone pair can be donated by the amines, because you know that Lewis base is an electron donor, whereas Lewis acid is an electron acceptor. So we will decide its basicity on that basis. Now amines are reactive and they can also act as a nucleophile. So both can be the case during the reaction of your amines, depending upon the other part of the reactant that we are taking. First of all, we will try to understand the basic nature of amines. So we know that if amines are basic in nature, they would react with acid, and to do this, they will donate their electrons. Now the acid will accept it and it will make a salt along with the base. For example, your BF3, which is boron trifluoride, is a Lewis acid because it has an incomplete octet. So it can accept an electron pair. Now ammonia is an electron pair donor. It can donate its electron to BF3. A coordinate bond has been formed. A complex has been formed of NH3 and BF3. So this will act as a Lewis acid base pair. So basically there is a formation of adduct. Next, how can we judge the basicity of your amines? For that we have something known as pKb value. We know that the acidic character is decided according to the K value. And the basic character will be of course decided by the Kb value. Now The greater will be Kb, the higher will be its dissociation, and more will be the product formation. This means that if the basic nature is good and the value of Kb is larger, then your base is having a greater tendency to donate the lone pair. Now talking about the pKb. So pKb is negative logarithm of your Kb, which means minus log Kb. It means that Kb is more, therefore pK will be less because of the negative sign. So basic nature of amines is directly proportional to Kb but inversely proportional to pKb. Larger the value of Kb and smaller the value of pKb, stronger will be your base. Now we will take some other kinds of nitrogen containing compound. Here we have three examples of it. First, for RNH2, the nitrogen atom is bonded to two hydrogen atoms and one R group. Therefore, 3 sigma bonds are in total. Now, it has one lone pair of electron. This gives it 4 regions of electron density, making it sp3 hybridized. Got it? We know that this is an example of amine, so it will be sp3 hybridized. What kind of amine? Primary amine. Then if we move on to R and double bond CHR, here the nitrogen is doubly bonded to a carbon atom in which we have one sigma and one pi bond, and then it is singly bonded to an R group which is due to one sigma bond. It also has one lone pair of electron. This results in 3 regions of electron density, so the nitrogen becomes sp2 hybridized. Moving on to the next, we have RCN. The nitrogen atom is triply bonded to a carbon atom where we have one sigma bond and two pi bonds. It has one sigma bond and one lone pair also. Got it? This gives it 2 regions of electron density, making it sp hybridized. So if we move on from single bond to double bond on to triple bond, we are seeing a change in hybridization from sp3 to sp2 to sp. Now, how will it affect the basicity? Let us look upon that. We know that greater with the percentage of s character of your hybridized orbital, that means lesser will be its basic character. Why is it so? So when a lone pair resides in a hybrid orbital with higher s character, it is more tightly held by the nucleus because of the closer proximity of your s orbital, and therefore it is less available for donation to form a new bond. This increased attraction for electron effectively makes the atom more electronegative and reduces its willingness to share or donate its lone pair, leading to a weaker basic character. Conversely, in a orbital with more p character, that means of course less s character, the lone pair is further away from the nucleus, making it more loosely held and more readily available for donation, thus increasing the basicity. So we can say that RNH2 is more basic than RCN. Okay, and your R and double bond CHR is in the intermediate part. Now, what is the name for all of them? We know that RNH2 is known as amine. This R and double bond CHR is known as your substituted imine, IMINE. Then we have RCN, which is cyno group, or we also call it as nitrile group. How are we saying that the S character is increasing from moving on from RNH2 to RCN? So it's very simple. If you look upon the hybridization, first we have sp3. That means your 100% character is divided into 4 orbitals, 3 of p and 1 of s. Since hybrid orbital are of equal energy and of equal shape, therefore the percentage distribution is also equal. Therefore, each one will get 25%. Therefore, 3p orbital will get 75% in total and 1s will get 25%. As soon as you move from sp3 to sp2, the percentage changes. Now, the 2p orbitals are getting 66.6%, where 33.3% is for each of them, and similarly your s is also getting 33.33%. But overall, s is getting 33.3% and p is getting 66.6%. So we can clearly see that the percentage s character has increased from 25 to 33.33. Lastly, in sp it becomes 50%, means the highest, and hence now the electrons are difficult to donate, and therefore RCN has the weakest basic character of all of them. Now we will discuss about the specific amines. So if you are keeping the amines, there are two phases which are possible. The one phase is where you can put it in liquid solution or in aqueous solution, that is in water. The second situation is that you can observe its basicity in the gaseous phase. In the solution phase, things are little different and quite complex. So we have to keep in mind all of those things. In solution phase, you must know that how you will relate, and in the gaseous phase, how to decide the order. We will understand this with the help of example. The order of basic character in case of methyl substituted amine and ethyl substituted amine in aqueous solution is as follows. In solution phase, both the factors will work. What are those two factors? The first one is the inductive effect and second one is the solvation effect, which is activated upon dissolution of your amines into water. Now, if the substitution of your nitrogen has more than one carbon, and in the second case there are two carbon, then both of them will have different type of behavior in the solution phase. If your number of alkyl group is increasing, that would make difficult for your amine to get dissolved into the water. Whereas the donation of lone pair is easier, means both the factors are acting in opposite way, the inductive effect and the solvating effect. The balance of these two will decide that which one will have a greater basic character. So this is completely experimental and you have to only remember it for the second and third. That means your methyl and your ethyl group. If I talk about the ethyl group first of all, then this is your order. The most basic will be the 2 degree. So here we have 2 degree, then we have 3 degree, and then we have 1 degree, and lastly we have ammonia. So remember this order, it is 2, 3, 1 for ethyl. Similarly, if I talk about methyl, there is a slight change in that. Then in the first, we have of course the 2 degree again, but after that we have 1 degree and lastly we have 3 degree. So for methyl it is 213 and for ethyl it is 231. The first and the last part are fixed, means the second degree will come first and your ammonia will come at the last. In between there is an interchange between 3 and 1. 3 comes first in your ethyl case in the solution phase, whereas in your solution phase 1 comes first in the methyl phase. Got it? Now moving on further. After that, this thing is being written here that your electron donating substituent such as methyl OCH3, they increases the basicity by increasing the electron density onto the nitrogen. Whereas electron withdrawing group such as NO2, which is nitro group, and your carboxylic acid, due to the presence of oxygen in them, they have decreased basicity. This order that you are seeing here right now is only true for your aqueous phase. Got it? So questions are asked multiple times from this place. Moving on to the next part, we have an order for the gaseous phase as well. Here only one factor is acting, which is greater inductive effect. So as a result of that greater inductive effect, 3 degree amine has the highest basicity, then comes your 2 degree and lastly your 1 degree, and then we have the ammonia. Remember, this is the order and the general order which is not so complex in the case of gaseous phase because of only one factor that is changing the situation, and that thing is your inductive effect. But in the case of your solution, that means in water, we have two factors and both of them are acting opposite to each other. So the situation is quite complex and we are getting a arbitrary order. For methyl it is 213, second degree, first degree and third degree, whereas for ethyl it is 231. You can easily remember this and you won't be asked question for the solution phase in the propanol or your butyl case. You have to be not worrying about that situation. Okay. Now we will move on to the next chemical property, which is acylation. As the name suggests, acylation is the reaction of your primary and secondary amine with an acylating agent such as acid chloride or acid anhydride to form an amide. In this nucleophilic substitution reaction, the nitrogen atom in the amine attacks the carbonyl carbon of the acyl group, replacing a hydrogen atom on the nitrogen with the acyl group. The reaction often requires a base like pyridine to neutralize the acid product HCl and drive the reaction in the forward direction. So in acylation, an acyl group, which is RCO, is added to the nitrogen atom of an amine. Primary amines have two hydrogen atoms bonded to the nitrogen, while secondary amines have only one. In acylation, the acylation reaction, a nucleophilic amine attack the carbonyl carbon of an acylating agent such as acid chloride, which is CH3COCl. This is an example of acid chloride, or your acetic anhydride. So it can be any acid anhydride. We will specifically talk about acetic anhydride. The amine's hydrogen atom is then replaced by the acyl group. Since a primary amine has two NH bond, it can only have one of them replaced by an acyl group, leading to the formation of N-substituted amide, RCONHR. In contrast, a secondary amine has only one NH bond available for substitution, so when it reacts, it forms a N di-substituted amide. Whereas your tertiary, which is 3-degree amine, do not have any hydrogen atom on the nitrogen, so they cannot undergo acylation to form the amides. So let us look on the reactions here. The reaction between ethylamine and acyl chloride is a nucleophilic acyl substitution, where the ethylamines nitrogen atom attacks the carbonyl atom of your carbonyl center of your acyl chloride, resulting in the formation of an amide and a hydrogen halide. Specifically, ethylamine, which is C2H5NH2, attacks acetyl chloride, which is CH3COCl, to form N-ethyl ethanamide, which is C2H5NHCOCH3 as given here. And along with that, we are getting an chloride. Now, as I said earlier, we use a base. Why we use it? To neutralize the acid that has been formed during the process as a byproduct. Now, why are we neutralizing it? What is the reason behind it? So the reason directly comes from the Leach-Atterial principle. The more you remove the product, the greater the reactant will be converted into product, because the reaction always proceeds in such a way so that any disturbance in equilibrium can be neutralized, and by removing HCl you are disturbing the equilibrium, and to restore the equilibrium the reaction will go in the forward direction. Got it? After that, we can take another example where we are taking secondary amine. Now, the reaction between diethylamine and an acyl chloride is a nucleophilic acyl substitution that forms a tertiary amide and a byproduct of hydrogen chloride. The reaction proceeds through a two-step addition elimination reaction. First, the lone pair of electrons on the nitrogen atom of the diethylamine acts as a nucleophile and attacks the electrophilic carbonyl atom of the acyl chloride. This forms a tetrahedral intermediate where the electron from the carbonyl double bond are pushed onto the oxygen atom. Next, the intermediate collapses as the carbonyl bond reforms, eliminating the chloride ion as a leaving group. Finally, the remaining hydrogen on the positively charged nitrogen is removed either by another molecule of diethylamine or by the eliminated chloride ion, resulting in the final tertiary amide product and an amine hydrochloride salt. Got it? Then after, moving on to the next reaction, the reaction between your aniline and the acid anhydride. So here we are using acid anhydride as the acylating agent. This is again a nucleophilic acyl substitution, commonly known as acylation, that forms an amide and a carboxylic acid. The mechanism starts with the nucleophilic nitrogen of aniline attacking an electrophilic carbonyl atom of the acid anhydride, pushing the pi bond electrons to the carbonyl oxygen. This forms a tetrahedral intermediate. The negative charge on the oxygen then again collapses to form the carbonyl double bond, which expels a carboxylate as the leaving group. Finally, a proton is transferred from the positively charged nitrogen to the carboxylate, yielding the neutral amide product and a carboxylic acid byproduct. You can clearly look it in the reaction, which is given here. So we are getting what? A substituted amide plus we are getting a carboxylic acid. So here your products are different from your acyl chloride, where we are using acid anhydride. Got it? Because here the counter anionic part was Cl in the case of acyl chloride. Here the counter anionic part is acid anhydride, which is resulting in the formation of acetic acid. Now moving on to the next. Our next reaction is carbylamine reaction. What is carbylamine reaction? The carbyl-amine reaction, also known as the Hofmann isocyanide synthesis, is a chemical test used to identify and distinguish primary amines from secondary and tertiary amines. The reaction involves heating a primary amine with chloroform CHCl3 and an alcoholic solution of strong base such as potassium hydroxide. This process yields an isocyanide written as RNC. So N is written first to indicate that it is not your cyanide but your isocyanide by your alkyl groups attached to the nitrogen. This is easily identified by its extremely foul smell and unpleasant odor. Along with that, we have potassium chloride and water as the byproduct. The mechanism proceeds through the formation of highly reactive dichlorocarbene CCl2 intermediate, which then reacts with the primary amine to form the isocyanide. Secondary and tertiary amine do not undergo this carbyl-amine reaction because they lack the necessary hydrogen atoms on the nitrogen for the reaction to proceed. The mechanism for the carbyl-amine reaction requires two hydrogen atoms to be removed from the nitrogen of a primary amine, RNH2, which is not possible with secondary or tertiary amine. Then this reaction is given here, which is your carbyl-amine reaction, and it is, as you know, it is used as a test for primary amines. A highly reactive dichlorocarbene intermediate is formed from chloroform and the base. In this specific case, methylamine CH3NH2 reacts with chloroform and alcoholic KOH to form methyl isocyanide CH3NC along with potassium chloride and water. Remember this reaction along with the stoichiometric coefficients. Moving on to the next chemical reaction, which is along with your nitrous acid. It is popularly known as HONO, H-O-N-O. Now talking about this reaction is different for different kind of amines. So basically your primary, secondary and tertiary amine react differently with the nitrous acid, which is prepared in C2 from a mineral acid like HCl and a sodium nitrite, NaNO2, primarily due to the number of hydrogen atom attached to the nitrogen. So primary amine react to form unstable diazonium salt Rn2+, which rapidly decomposes at room temperature to produce alcohol and release colorless, odorless nitrogen gas N2. So here is the reaction. When an aliphatic primary amine reacts with nitrous acid, it forms first a very unstable aliphatic diazonium salt, which immediately decomposes. This decomposition releases nitrogen gas and a carbocation intermediate, which is then typically converted to an alcohol with minor products like alkenes also forming. The rapid evolution of nitrogen gas is a key characteristic of this reaction and is often used for the quantitative estimation of amino acids and protein. Then what about aromatic amine? So they react with nitrous acid at low temperature, which is 0 to 5 degrees Celsius, to undergo diazotization, forming a stable aromatic diazonium salt, which is a key intermediate for synthesizing other aromatic compounds. This reaction typically carried out by mixing the amine with an acid like HCl and sodium nitrite, producing the diazonium salt and water. All of this is done at 0 to 5 degrees Celsius because your diazonium salt is not stable at high temperature. For example, we can see the reaction here. Anil is reacting with nitrous acid. So it can be written as either HNO2 or the precursors of your HNO2 can also be written NaNO2 plus HCl. Next, aromatic diazonium salts are highly versatile synthetic intermediate due to exceptional leaving group ability of the diazonium group, which is N2+. The reactive state of this salt allows them to undergo a variety of useful transformation in organic synthesis, including reactions where the nitrogen is replaced by another group, example Sandemeyer reaction, and coupling reaction where the nitrogen is retained to form azodides. So this delicate balance between stability at low temperature and the reactivity with a suitable reagent is the defining characteristics of their reaction state. Now we will see the specific reaction with secondary and tertiary amine as well. A secondary amine will react with nitrous acid HNO2 to form N-nitrosamine. We will see the structure, which is a yellow oily water insoluble liquid. The reaction involves the nucleophilic attack of the amine on the nitrosonium ion NO+, followed by the elimination of water molecule to produce the nitrosamine product. This reaction is distinct from those of primary and tertiary amine, and its product N-nitrosamine are known to be potent carcinogens. N-methylaniline is a secondary aromatic amine, and when it reacts with nitrous acid HNO2, it undergoes a reaction called N-nitrosation. This reaction does not produce a diazonium salt as happens with primary aromatic amine. Instead, the hydrogen atom on theamine's nitrogen is replaced by a nitroso group, okay, NO, resulting in the formation of N-nitroso N-methylaniline. This product is often described as a yellow oily substance that is insoluble in water. So this indicates that your reaction is terminated. After that, what about tertiary amine? So they react with nitrous acid as well, but they form an acid-base neutralization reaction. How? Due to the formation of a water soluble ammonium nitrite salt. Of course, if it is a salt, it will have a positive and a negative character, and you know it very well that positive and negative charges are stable in the water solution. Unlike primary and secondary amines, tertiary amines have no hydrogen atom attached to the nitrogen, which is necessary for the formation of diazonium salt or nitrosoamine. While the initial salt formation is the primary reaction, if the tertiary amine contains an alkyl group with alpha protons, warming the solution can cause a slow decomposition of the salt to yield an N-nitrosoamine and an alcohol. So here is your corresponding reaction. Example, the triethylamine will form triethylammonium nitrite, a colorless solution. In contrast, tertiary aromatic amines undergo electrophilic aromatic substitution to form a nitroso derivative of a secondary amine and an alcohol. So if you look upon to the structure here, we have of alpha hydrogen to proceed this reaction further, or else you will only get your salt. What is that alpha hydrogen? So this C2H5 which is attached to nitrogen, so the next carbon is containing two hydrogens. Therefore, alpha hydrogen is those hydrogens which are attached to those carbon which are next or adjacent to the functional group. Got it? After that, since this reaction gives different products for different amines, therefore it can be used as a distinguished test for primary, secondary and tertiary amine, because primary amines are giving the reaction which is resulting in the formation of alcohol. Secondary and tertiary amine gives different product. So we can use this test to distinguish between primary, secondary and tertiary amine. I hope this part is clear to you, and these are important for you as well. Next, we'll move on to electrophilic aromatic substitution, or electrophilic substitution reaction in simple, which is also abbreviated as ESR. An electrophilic substitution reaction is a chemical reaction where an electrophile, which is simply an electron-seeking species, replaces a functional group in an organic molecule. This is particularly common in aromatic compound like benzene, where the electron-rich ring is attached by the electron-deficient electrophile. Electrophilic substitution reactions in aromatic amines like aniline occur readily due to the activating and ortho-para directing effect of the amine group, which is NH2, amino group, which is NH2. The lone pair of electron on the nitrogen atom delocalizes into the benzene ring, increasing its electron density and its reactivity as well. Common reactions include halogenation, nitration and sulfonation, which can lead to multiple substitution if the amino group's high reactivity is not controlled at all. So, example, the bromination of aniline is a rapid electrophilic aromatic substitution reaction that yields substitution at 3 multiple positions simultaneously, giving us 2,4,6-tribromoaniline. The amino group on the aniline is a strong activating group that makes the benzene ring highly electron rich, causing it to react almost instantaneously with bromine even under mild condition to produce a white precipitate of tribromo product. After that, we can clearly say that the major drawback of your aniline bromination is the overreaction, which leads to instant formation of 2,4,6-tribromoaniline instead of desired mono or di substituted products. Why is it occurring? Because of the amino group, which is a strong activating group. It continuously donates the electron onto the benzene, increasing its electron density, and hence substituting all available positions such as ortho and para at the same time, even at milder conditions. So now we will see that how we can do selective bromination rather than overreaction. Bromination of aniline is not a selective under normal condition. We know it from the previous reaction due to strong activating effect of amino group, which makes the ring highly reactive and results in the intermediate tribromination, immediate tribromination. To achieve selective bromination, the reactivity of the amino group must be reduced by temporarily protecting it, most commonly by converting it into an amide with acetic anhydride. This product this produces an acetanide intermediate which undergoes less vigorous para-selective bromination before the protecting group is removed. For the selective monobromination of aniline, the amine group must be protected to reduce its strong activating effect on the benzene. As direct bromination rapidly yields the over-brominated product 2,4,6-tribromaniline, first aniline is treated with acetic anhydride or acetyl chloride in the presence of pyridine to form acetanilide. The lone pair of the nitrogen becomes involved in the resonance with the acetyl group's carbonyl, which reduces the electron donating ability of a nitrogen group towards the ring and sterically hinders the ortho product. Next, the now moderately activated acetanilide is brominated with molecular bromine in solvent like acetic acid, and the reaction proceeds via an electrophilic aromatic substitution mechanism. The brominium electrophile selectively attacks the more accessible electronically favorable para position, forming the major para product, which is bromoacetanilide. Para bromoacetanilide. Finally, the protecting group is removed by acid or base catalyst hydrolysis to regenerate the amino group and yield the desired para bromoaniline. So in this case, in this way, all the reaction is being carried out. So if you have a doubt till now, you can ask your question, anyone who have joined the class. Anyone who has a doubt till this part? Okay. So moving on to the next electrophilic aromatic substitution, which is popularly known as nitration. Now, direct nitration of aniline with a strong acidic nitrating mixture such as concentrated HNO3 and H2SO4 is a problematic and generally avoided process. In the presence of a strong acid, the amino group NH2 of aniline gets protonated. You know it, it's a base, so it will accept the hydrogen ion from the nitrating mixture to form anilinium ion, which is NH3 plus. As a result of this, if you do the direct nitration of aniline, a complex is formed that results in the formation of orthopara and meta-nitroaniline along with undesired terry oxidation product. You can see here that the major product is not your ortho and para as well. It is ortho as well. Your para and meta product are almost formed in the equal amount, which is problematic. Why is it happening? This happens because the reaction is performed in a strongly acidic medium, which causes the amino group NH2 to undergo two competing reaction pathways. The first pathway involves the unprotonated aniline acting as an ortho-para directing activator. The second and often dominant pathway involves the amino group being protonated to form the anilinium ion NH3+. This positively charged group is a powerful electron withdrawing deactivator, and due to its inductive effect, it directs the nitronium ion to the meta position. The mixture of product is therefore formed from a combination of nitration on the unprotonated aniline, forming ortho and para products, and nitration of the protonated anilinium ion, forming meta product in somewhat major amount. You can clearly see in the reaction, since your inductive effect is distance dominated, so as we are moving away from the NH2 group, which is becoming NH3 plus, we are getting a more substitution in the position of para because it is very far away from this NH2 group, and hence it is formed in the major amount. Then just next to it we have 47%, and it is again due to the distance dependency. But as soon as you move close to this para or NH2 group, you are getting only 2% of ortho product. This is making clear that protonation of NH2 is going on during the nitration of your aniline. This anilinium ion is a strong deactivating and a meta-directing group, which leads to the formation of significant amount of undesired meta-nitroaniline product along with the expected ortho and para product. Now, during the reaction in a strong acidic medium, the basic aniline is protonated to form the anilinium ion. You can look here, we have NH3 plus here. Next, unlike the lone pair on the nitrogen of your aniline, which activates the ring for ortho and para substitution via resonance, the nitrogen in the anilinium ion carries a positive charge and has no lone pair available. This positive charge exerts a strong electron withdrawing inductive effect on the benzene ring, deactivating it and decreasing the electron density, particularly at the ortho and para positions. With the ortho and para position made highly electron deficient, the incoming electrophile is directed to the relatively more electron rich position, which is meta, leading to a higher yield of meta product. Got it? So there is no chance of minus R effect, remember it, because nitrogen has already made 4 bonds, which is the max possibility for nitrogen. So that is the reason it cannot show minus R, but it is capable of showing the minus I, and that is the reason you are getting the product in the order of para, meta and then ortho. Now the question is that, can we produce a single product during nitration? Yes. The highly activating amino group in aniline would cause rapid non-selective and often destructive oxidation from the past experiences that we have seen. And if it is subjected to a direct nitration with a standard mixture of concentrated nitric and sulfuric acid, by reacting aniline with acetic anhydride, the amino group is converted into less activating acetamide, which is NHCOCH3 group, which reduces the molecule's overall reactivity and prevents side reactions like oxidation. The acetamide group will still, while still an orthopara director, provides better control over the reaction, resulting in a more predictable formation of para nitroacetanilide product due to less steric hindrance, which is then easily separated from the minor orthoisomer. Finally, hydrolysis of the acetamide group under acidic or basic condition removes the acetyl group, which is acting as a protecting group, to yield the desired nitroalanine. So basically, the nitrogen's lone pair, which was being donated onto the benzene, is now distributed onto your carbonyl center as well. So basically, there is a partial delocalization over the benzene ring as compared to the previous situation, and hence your intensified nitration is not seen in this case. Rather than that, we are seeing a controlled nitration at para position selectively. And how we are doing it? By delocalizing the lone pair of nitrogen onto a different group. Yes, it has test platforms as well. Now, aniline does not go Friedel-Crafts reactions because its lone pair of electron on the nitrogen atom causes an acid-base reaction with the Lewis acid catalyst such as AlCl3. You know it very well that AlCl3 is a Lewis acid and it can accept electron pairs, whereas your amine is a Lewis base. So they are a perfect pair for acid-base reaction, and they do so. And by doing so, they form a salt which deactivates the aromatic ring by placing a positive charge on the nitrogen atom and preventing electrophilic attack, thus making the ring unsuitable for substitution reaction. The resulting complex inhibits the Friedel-Crafts reaction and no alkylated or acylated product is formed. I hope this part is clear to you. So basically what are we doing here is we are taking 3 scenarios. First of bromination. Okay. So in bromination phase, we are seeing that the bromine is getting attached onto the aniline ring on 3 parts, on both the orthos and the remaining para. Whereas in the case of your nitration is resulting in the major formation of your meta product rather than ortho and para product. Means the part of your para product is now shared with the meta product as well, which is of course not the required one. To counter that, we have introduced a acetylation center, okay, on the nitrogen. What is this acetylene group does? It delocalizes the nitrogen's lone pair onto the carbonyl. So now the partial delocalization is on benzene as well as the acetylation group. Got it? Now once the substitution is done, the electrophilic aromatic substitution is done, we can easily remove it. So remember the step to remove it. It's very, very important to remember this step also. And how it is done? By simply hydrolyzing it with an acid or a base. This will completely remove your COCH3 and restore your NH2 group. Lastly, the Friedel-Crafts alkylation is also difficult for your aniline, because aniline is a perfect example of Lewis base and your AlCH3 is a perfect example of Lewis acid. So they quickly react with each other to form the salt, which deactivates the ring and prohibits further electrophilic aromatic substitution. Now, moving on further, we will see the next reaction, which is sulfonation reaction. So this is somewhat magical. You will see that a magical thing is happening here because it might confuse you. We have not seen a mechanism for this so far, and hopefully we'll not see for it for the same. Okay, we will only remember it through the reaction. So sulfonation of aniline is a two-step process that ultimately yields para-aminobenzene sulfonic acid, or sulfanilic acid, also known as sulfanilic acid. This reaction is initiated by treating aniline with concentrated sulfuric acid, which is in acidic medium. Okay, and it is done at 453 to 473 Kelvin. So basically what will happen in the initial step, the basic amino acid NH2 of an aniline reacts with acid to form anilinium hydrogen sulfate, which is C6H5NH3 plus and HSO4 minus. So here your H2SO4 has donated one H plus to NH2 to form the NH3 plus. Then after, since now your nitrogen has a positive charge in the intermediate, therefore it will deactivate the benzene ring and it will form a salt with the HSO4 minus. Got it? With this prevents your direct electrophilic substitution. The second step involves the heating of your same anilinium hydrogen sulfate at 453 to 473 Kelvin. Now, during this heating, an intramolecular rearrangement occurs and the sulfonic acid SO3H migrates to the sterically favored para position on the ring to produce sulfanilic acid, which exists predominantly as the Zwitterian or internal salt. So why are we calling it as Zwitterian salt? If you see in the structure, then your SO3H is now donating one proton to the NH2 to form NH3 plus, and this is occurring because your SO3H is a better acid and your NH2 is a good base. So an acid base, an intramolecular acid base reaction is taking place here, resulting in the formation of Zwitter ion. So always remember, whenever you see a positive and a negative charge on the same molecule, you will call it as Zwitter ion. We will see the example of the same in the case of biomolecule chapter. Okay. So this was all about the theory part. Now we'll move on to the question part. So just wait for a while. I will open the question in short time. So here is the first question. The question asks you to determine which of the given option is the most volatile. So we have four options here. In the first option, we have a primary amine. In the second option, we have a tertiary amine. In the third option, we have the secondary amine, and the last option we have a simple hydrocarbon. So which one will be the correct one? 2, 4, 1 and 3. In this question, you have to simply identify that what are the intermolecular forces that are acting between the molecule. If you take the first, second and third case, which are of similar kind of functional group because they all are containing nitrogen, in all of this, the degree of your amine is changing. The 1 degree and your 2 degree amine are capable of doing intermolecular hydrogen bonding interaction, whereas your second degree is your second option, which is your third degree, is not capable of doing so. But it has a dipole-dipole interaction because of different electronegativity of your nitrogen and carbon. So this is for the first three, 1, 2 and 3, in which all are amines. But for the fourth one, the case is completely different. This is the case of your simple hydrocarbon, where we have no intermolecular interaction apart from the van der Waals force. So van der Waals force is of course present in all of them, but apart from that, it has no dipole-dipole interaction or your hydrogen bonding. Now it's very clear which one will be the correct answer. So you have to tell that which one is volatile. That means out of these compound, which can be converted directly into the gas phase without any extra effort. So that is something which is indication of your volatile nature. So I hope it's a very easy question. You look upon the option. Option A is 2, B is 4, C is 1 and D is 3. So here the options are shuffled. You are not given in the order of your given compound. It is quite shuffled. So I am giving you some time to answer this question. I've already hinted about this question. Just think and give it in the comment section. Okay, your time is up. So the correct answer is option B, which is 4. Now let us discuss the solution. Yes, the correct answer will be. So first and second order amines form hydrogen bond between molecule due to presence of lone pair on the nitrogen atom. This intermolecular hydrogen bonding increases the strength of the intermolecular forces, leading to higher boiling point compared to the third degree amines. And hydrocarbon of similar molecular mass first and second first and second order amines are less volatile than the third amine and hydrocarbon. This is because stronger intermolecular forces requires more energy to overcome, thus raising the boiling point and making them less volatile. Further, the polar CN bond in tertiary amine make them more polar than hydrocarbon, which are almost non-polar in nature. This polarity affects how this molecule interact with other substances. Unlike hydrocarbon, which has weak intermolecular force, tertiary amine can form strong interaction due to their dipole-dipole interaction. This property influences their stability and reactivity in the chemical reaction. Therefore, third degree amine have stronger intermolecular forces than hydrocarbon, and hence they can do dipole-dipole interaction. Even though these are weaker than the hydrogen bond, but they are still stronger than the hydrocarbon of similar molecular weight. And as a result of that, your hydrocarbon has the least boiling point and hence it is most volatile in nature. I hope this is clear to you. Now you can arrange all of them in the decreasing or increasing order if you want. So first you have hydrocarbon, then they have 3 degree amine, then we have 2 degree, and lastly we have 1 degree. Now what are the conditions for hydrogen bonding? So your hydrogen must be attached to an electronegative element. So the specifically 3 elements are there: nitrogen, then we have chlorine, then we have oxygen. If your hydrogen atom is attached to these 3 electronegative elements and 1 fluorine is there, these 3 electronegative elements, then and then only there is a possibility of hydrogen bonding. Chlorine is not included in that. Fluorine, nitrogen and oxygen. And it will do a hydrogen bonding with these 3 atoms only, with the lone pair of these 3 atoms only. So remember this criteria. After that, our next question is here. The question is asking us to identify which of the given option is the strongest base in water. Okay. So we have 4 options available. One is CH3NH2. It is what? A primary amine where methyl group is present. Then in the second part, we have again a primary amine. But in this case, we have a CN attached to that. You can clearly see it here. In the option C, we have a secondary amine and it is attached to methyls, two methyl group. And lastly, in the D option, we have two alkyl groups and it is also an example of secondary amine where one is an aryl. So one is an aryl because it is C6H5 and the other is methyl. Got it? Now you have to tell about their basic character in the aqueous phase. Okay. So how you will do it? Just try this. It's a simple one. So I'm giving you some time to solve it. Just try to draw the expanded structure and do not try to conclude it from the condensed formula. Then you will get your answer easily. Remember the order. It is 213 for methyls and 231 for ethyls. And we have some more informations like in the second group, in the B option, the CN group is present, which will decrease the basicity by attracting the lone pair because it is electron withdrawing group. Similarly, in the D option, which is a 2-degree amine, but the lone pair are being delocalized onto the benzene because here the substituted amine is being substituted with a benzene ring. So the correct answer would be option C, which is CH3 whole twice NH2 NH, means a 2-degree amine and a methyl one. Now let us discuss the solution. So your dimethylamine is a strong base because the two methyl groups attached to the nitrogen atom exerts a plus I effect. This effect helps to stabilize the positive charge that forms on the nitrogen after it captures a proton. The plus I effect from the methyl group increases the electron density around the nitrogen, making it more capable of donating a pair of electrons and thus enhancing its basic character compared to amines with fewer alkyl groups. So what are those with fewer alkyl groups? So let us have a look on other options. So CH3NH2 is a methylamine, a primary amine. The nitrogen atom is bonded to one alkyl group, which is CH3, so less inductive effect. Methylamine is a weak base and it's commonly used in organic chemistry for its reactivity and basic properties. Moving on to the next one, which is again a 1-degree amine. Apart from that, it is also attached to a electron withdrawing group, which is cyanido. Okay, so it will pull out the electron, which is specifically your lone pair here from the nitrogen and thus reducing its basicity. Lastly, we have a 2-degree amine, but the problem is that in this case, the benzene ring and the methyl group are both connected to the nitrogen, making it a 2-degree amine. But the lone pair is not free as it participates in the resonance with the ring and making it less available for donation. This basicity is lesser than alkyl amine. Got it? Now, moving on to the question 11. This question asks you to identify which compound from the given option is the strongest base when dissolved in water. So, four options are here: trimethylamine, then B, aniline, C, dimethylamine, and D, methylamine. Okay, so it's a very easy one. So, I'm giving you some time to think about it. Just tell me the answer. Remember, you have to think about it in the aqueous solution. Got it? Your time starts now. I'm giving you 2 minutes to solve it. It's an easy one. You just have to draw the structure and you will get your answer easily. So what will be the answer? Just write it in the comment section. Okay. So let us move on to the correct answer. The correct answer will be C, which is dimethylamine. Let us discuss the solution. So dimethylamine is the strongest base in aqueous solution because of two main reasons. We know it, the solvation and the inductive effect. The solvation effect refers to how Well, the base interact with water molecule, making it more likely to accept a proton. Yes, the correct answer would be C. The inductive effect involves the electron donating nature of the methyl group, which increases the electron density onto the nitrogen atom, making it more willing to accept a proton. These factors together make dimethylamine more basic than other amine in the water. Then, the order of basic strength of a given compound in aqueous solution is as follows. Dimethylamine is the strongest base among all, followed by methylamine and then trimethylamine. Lastly, we have aniline because aniline's lone pair are being delocalized. So, trimethylamine is a third degree amine, meaning the nitrogen atom is bonded to 3 carbon atoms. Trimethylamine is a lower basicity than dimethylamine, primarily due to steric hindrance. The three bulky methyl groups in trimethylamine creates a crowded environment around the nitrogen atom, which makes the lone pair of electron less accessible for protonation compared to the methyl groups in dimethylamine. This steric hindrance outweighs the electronic donating effect of the third methyl group. Got it? What about aniline? So it's a weaker base than dimethylamine because nitrogen atom's lone pair of electron in aniline is delocalized into the benzene ring through plus R or resonance effect, making it less available to accept a proton. In contrast, the methyl groups in dimethylamine are electron donating, which increases the electron density on the nitrogen and make the lone pair more available for protonation. Next, we have this methylamine. It has lower basicity than dimethylamine because dimethylamine has two electron donating methyl groups, which increases the electron density on nitrogen atom, making its lone pair more available for donation. In contrast, methylamine only has one methyl group. So, the nitrogen atom has less electron density and is less available to accept a proton, making it a weaker base. So, 2 degree amine is something which is a balance of this solvation effect and your plus I effect. Therefore, it is always coming at the first. Now, moving on to the next question. The question asks about the order of basicity of amine when they are in the gaseous state. So, here you have to tell them in their gaseous order of their basicity. So, option A 1 degree, 2 degree, 3 degree ammonia. B 3 degree, 2 degree ammonia, 1 degree. C 3 degree, then 2 degree, then 1 degree, and then ammonia. And lastly, we have ammonia 1 degree, 2 degree, and 3 degree. Your time starts now. Just write your answer in the comment section. I will just wait for 1 minute and then we'll move on to the correct answer. Remember, in the gaseous phase, we have nothing such as solvation enthalpy. We are only here to consider the plus I effect. Okay, so go with that. Okay, so moving on to the correct answer, it will be option C, which is 3 degree, 2 degree, 1 degree, and then ammonia. So let us discuss the solution. In the gaseous state, when the number of alkyl groups on a nitrogen atom increases, the electron density around the nitrogen also increases. This is because alkyl groups are electron donating groups through the plus I effect. As more electrons are available, the nitrogen atom willingly becomes more willing to donate them, which enhance its ability to accept proton. Therefore, the basicity of your compound increases with the number of alkyl groups. This is because your basicity depends upon the availability of the lone pair on the nitrogen atom for protonation. In gases, there is no solvation effect, so the inductive effect is the dominating factor. Moving on to the correct option, we can just write it that the correct order of basicity in the gaseous state would be 3 degree, 2 degree, 1 degree, and then amine. Remember, here only one factor is dominating, which is your electron donating tendency through plus I effect, and hence making your tertiary group more eager to accept the H plus. Got it? Here's our next question. It is asking us to identify which substance form the given option is the strongest base. It provides a list of different molecules and you need to determine which one has the highest basic strength, or you can say highest Kb value or lowest pKb value. Your time starts now. What is the correct answer? Just write it in the comment section. Remember, in most of the cases where your nitrogen is directly attached to the benzene ring, there will be delocalization, okay, of the lone pair, and they will be less available for donation in compared to those nitrogens which are not directly attached to the benzene ring. Okay, so with this we can clearly say, with this statement I can clearly say that the correct option would be D, which is benzylamine. Now why benzylamine? So in the A, B and C options, we can clearly say that all are aromatic amine because the nitrogen is directly attached to the benzene ring. As a result of this, in all of these three, nitrogen's lone pair are being delocalized onto the benzene ring, and it is delocalized through the resonance effect, and hence they are less available for donation. Okay. Now, if I look on to the option number D, so let us consider option number D. In the benzylamine, the NH2 group is not directly attached to the benzene ring. Instead, it is acting as a end towards the CH2 group. You can clearly see that we have CH2 group and then we have the NH2. So basically, this group you are seeing right now is donating its electron by plus I effect. So it will be considered as the strongest base because the electrons are being getting a greater charge due to the alkyl group attached to it. And there is no case of delocalization because nitrogen is not directly attached onto the benzene ring. So this is a very good example of how you can just compare the basicity using the plus M and plus I effect. Then next question asks us about the basic strength of amines in water. It gives option of different amines and asks which one has the smallest pKb value, means the highest Kb and the greatest basic character. You need to determine the amine with the lowest pKb from the given choices. pKb is a measure of basic character, so the smallest pKb means the strongest base. The question only wants to know which amine has the greatest basicity in simple terms, I would say. So your time starts now. Just write your answer in the comment section. Then we'll move on to the correct answer. Remember, we have to look upon them in the aqueous solution, not in the gaseous phase. So we have a different order for it, which is kind of arbitrary. So it is 213 for your methyls and 231 for ethyls. Now, with this, we'll move on to the correct option. Yes, the correct option would be A, Varsha, which is CH3 whole twice NH. So it's a very simple one. We have discussed a lot about it. In case of aqueous solution, the basic strength of aliphatic amine depend upon two factors, solvation effect and the inductive effect. Therefore, a balance of two will create the order of basicity. Here you can see the order goes as 2 degree, 1 degree and then 3 degree. And in the last, we have this C6H5NH2. Why are we keeping it at the last? Because here the lone pair is not itself available at the first side. In all of these three cases, there is no case of delocalization, but in the case of aniline, there is complete delocalization. And therefore, the delocalization will dominate over all cases. Because in these cases, at least the lone pair is present on the nitrogen. But here, it is being delocalized, being removed, or we would say it is partially distributed. And hence, we can clarify that it is the weakest one. Got it? Now, moving on to the next. The formula we know that for pKb we have minus log Kb. This is used to express the basic dissociation constant in a more manageable form. The pKb helps simplify complications of calculations involving weak bases. A smaller pKb means a stronger base and it indicates a larger Kb value and a good base. Further, dimethylamine has the smallest pKb value, meaning it is the strongest base among the given compound. This is because of the two methyl groups that donate electron density to the nitrogen, increasing its ability to accept proton. In contrast, phenylamine has the highest pKb value because the nitrogen is attached to an sp2 hybridized carbon in the benzene ring. The conjugation delocalizes the lone pair of nitrogen, reducing its basic character. Thus, electron donation becomes difficult while conjugation increases. Okay. Here is our next question. The question asks us to arrange the given compound in the order of the increasing basicity. So this is a very interesting question. It provides a list of compounds that wants you to determine which one is the least basic and which is the most basic. Then write them from the weakest to the strongest base. So this is the order that you will follow. If I look upon the options here, then they are quite different from each other. Your 1 degree amine is given in the first option, but in the second option we have a imine, I-M-I-N-E, because nitrogen is attached to a double bond. Then after we have a imine and a amine both present in one single compound. Where in the fourth option we have a 2 degree amine, where in the first option we have a 1 degree amine. So all of them are quite different in their structural aspect. The four options, or you would say the four orders, are given here, and you have to decide that which is the correct order of their basicity. Your time starts now. Just give your answer in the comment section. It's a good question. Okay, so your time is up. Now, why did I say it's a good question? If I look upon the four options, then in the first glance, you would expect that your NH2 group, which is being attached in the case of 1 and 3, are quite similar. So, how you will differentiate between the basicity? In this very basic place comes your resonance effect. So, let us discuss about them. In the second molecule, the nitrogen is sp2 hybridized and thus a little electronegative than the sp3 hybridized nitrogen. So the basicity decreases in the first glance as well. In the third molecule, the lone pair of nitrogen participates in the resonance and increases the basicity. You can see here in the structure as well that a lone pair is being delocalized onto the nitrogen. That creates a negative charge upon the nitrogen. You would also talk about them in terms of the conjugate acid that is formed, because that conjugate acid is stabilized through delocalization. You can clearly see here that after the formation of the conjugate acid, your double bond is being delocalized onto two positions and it is creating equivalent resonance because both of them have the same structure. And whenever there is a case of equivalent resonance, a very stable molecule is formed. Got it? You can take the example of your COOH. And why is it so? Because here two molecules are there which have the same structure and they both are contributing to the highest stable structure of the given molecule. Got it? Now, from this discussion, it is very clear that the third one is the one which is having the highest basicity and the second one is the one which is having the lowest basicity due to the percentage S character increase. Got it? How much it is in the given compound? It is 33.33%. Now we have to compare about the first and fourth one which are present in the middle part. How you will compare them? To compare this, you can easily see that in the first, this molecule, we have a sp2 hybridized carbon. Okay. And in the last one, we have, in the fourth one, I would say, we have a sp hybridized carbon attached on both sides, but the degree is different. Fourth one is 2 degree and the first one is 1 degree. So how you will differentiate between these two? You have to differentiate between the fourth and the first one. So it's very simple. Your fourth one will have a higher basicity because it's a 2 degree compound. Okay. Either you consider it in the basic phase, in the aqueous phase or in the gaseous phase. You have already seen it that in both the phases, your 2 degree amine is the dominating one. Now from this, if I compare to the first one, okay, if it is compared to the third one, then there would be a dilemma. You have to first know that whether the given situation is a aqueous or a gaseous phase. But here the comparison is between 3 degree and 2 degree and 1 degree, and it's very clear that the 2 degree amine is always a dominant one. Got it? Therefore, fourth will come first before the 1, and then the order goes as 2, 1, 4, 3. If I try to eliminate the options, you can just look for the last one and the first one, and there is only one option which goes with that order, which is option C. So from that perspective also, you can just execute your answer giving option. Okay. Now, moving on to the next question. So it's a very good one. A compound with molecular mass 180 U is reacted with CH3COCl, which is acyl chloride, to form another compound with molecular mass 392 U. We need to find how many amino groups are present in one molecule of the original compound. The question gives us the molecular masses before and after acylation. Ask for the number of amino groups in the original compound. Your options are 2, 5, 4, 6. So, how you will solve it? So, first of all, you write the reaction related to it. Okay. The question is saying that a compound is there with a molecular mass 180 U and it is acylated. And the acylating agent which is used is CH3COCl. After the reaction, we are getting a compound with molecular mass 392 U. Now you have to identify that how many amino groups are present per molecule. So it's very simple to guess. You will keep the alkyl group as R and see that what is the difference between the molecular mass. Okay, so this was a hint. Just try to solve it. I will give you the answer in few minutes. So your time starts now. So it's a difficult one. I will give you more time, 3 minutes, hopefully. You have to only see that what is the molecular mass difference that you are observing. Okay. So there will be one removal of hydrogen and addition of CH3CO group. If one CH3CO group is being added, what would be the increase in the molecular mass? And if 2 is added, what would be the increase? With that, you have to judge that whether that increase is according to one addition or addition of 2 acyl groups. And that will quickly give away your answer. You don't have to worry about the alkyl part of your amino group at all. So 2 more minutes are left. Just give your answer in the comment section. First of all, write the whole reaction. Okay. Okay, so time is up. Let us move on to the solution. For those who have tried to solve it, the correct answer is option B, which is 5. Now let us discuss the solution. So here is a general reaction that we can start as the with which we can start as the primary part. During acylation, as I said, one of the H group will be removed and that will be replaced by COCH3 group. Got it? In this reaction, you know that each COCH3 group replaces one hydrogen in the molecule, and that would result in an increase in molecular mass of 42. But what is the increase that you are seeing? There is a total increase of 210. So basically, you have to consider using the unitary method. So for one unit, it is 42, and there is an increase of 210 units. So you will divide to count the number of units 200 by 42. So that will give you 5 is the answer. Now you would question me that why you have taken this reaction as the primary reaction. So it is just for the reference. It is not the final verdict. Okay. So we have taken an arbitrary reaction and then we have played our unitary method to get at the answer. So again, I will explain it because it's a difficult one. During your acylation process, what is occurring? If I take a simple reaction, one hydrogen is being removed and in place of that, one COCH3 group is being added. If I just try to calculate the difference, means the amount of molecular mass which is added. So the mass of one CH3 group is how much? 12 plus 3, 15, and 15 plus 12, 17, and 17 plus 16. So that will give you 23, right? Again, let us add it. So we have 1 CHC, then 2 C. That means 12 to the 24. Okay, 24 plus 16. So 24 plus 16 means 40 and 43. Right. Okay. So one CH3CO group means 42. And removal of one H is also going on. So that will give you 42. Got it? So for each CH3CO being added, there is an increase in molecular mass by 42 units. Now, if I look upon to the given condition, you can clearly see that the increase in molecular mass is of 210. So subtract it, 390U minus 180U. So it will clearly give you 210U. If there was an increase of one CH3CO group, then the molecular mass would have been increased by 42. But it is not the case. Means there is an greater increase in of CH3CO group, or you can say that there are greater number of NH2 groups which are present in the given molecule. How you will count it? So it's very simple. So for one CH3CO group, if it is 42, then for 210, it would be 210 by 42. Therefore, the total number of groups which are being added upon to the given reactant is 5. Okay. I hope this clears your doubt. Now, if you have a doubt, you can just ask it in the comment section, or we would conclude our today's lecture. Any doubt in this part? So this was all for today's lecture. Thank you for joining the session. I hope you enjoyed it.
Hello student, in today lecture we are going to discuss the theory part of hyperbola. So in this we will discuss all the result that is related to hyperbola. So this is our disclaimer part. So this is our index. So first we will explain the definition of a hyperbola, like what is hyperbola. Then we will see the sum terms that is related to hyperbola, and then we will see the equation of hyperbola in standard form. And after that we will discuss tangent to a hyperbola, and then we will discuss some result on tangent, and after that we will discuss normal to a hyperbola, and then we will discuss some result on normals, right? And after that we'll see that what is pole and polar of a hyperbola, and then we'll see that what is conjugate points and what is a conjugate lines, and then we'll discuss what is a director circle, and then we'll discuss what is a asymptotes, and after that we'll see some result on asymptotes, right? And then we'll discuss the rectangular or equilateral hyperbola. We'll see that what is that, and then we'll see that rectangular hyperbola of the form x square minus y square equals to a square, right? And after that we'll see that rectangular hyperbola of the form xy equals to c square, right? So this is your index. So we will see all these things in today lecture. So first let us start with what is hyperbola. So we'll say that a hyperbola is a locus of point in a plane which moves such that the ratio of its distance from a fixed point and its distance from a fixed line is always constant, and this constant is always greater than 1, and we'll say that that fixed line as a directrix, and we'll say that that fixed point is a focus, right? So in this figure you can see that we have a point P, right? So when we'll take a distance from the fixed point S, so this is, we'll say that that is this is PS, and when we'll take the distance of this point from a fixed line, right? So we'll say that that is PN, right? So you can see that when we'll take the ratio of SP divided by PN, so this is equals to E, and where the value of E is greater than 1, right? So here we have discussed that what is hyperbola. So now we are going to discuss some important terms that is related to hyperbola are given below. You can see that. So the first term is vertices. What is that? So the point A and A dash, where the curve cuts the line that join both focus S and S dash, right, are called the vertices of the hyperbola. In this figure you can also see that we have 2 points A and A dash. And next we are going to see that what is transverse and conjugate axis. So the transverse axis is the one that is along the line that passes through the focus and is perpendicular to the directrix, right? So and also we can say that transverse axis is a type of line. And what is the conjugate axis? So we'll say that the conjugate axis is the one that is perpendicular to the transverse axis, right, and passes through the midpoint of the focus, right? So here we have discussed that what is the conjugate axis, and also we have discussed that what is a transverse axis, right? So the transverse axis is the one that is along the line that passes through the focus and is perpendicular to the directrix, right? So this is the transverse axis, and the conjugate axis is one that is perpendicular to the transverse axis and passes through the midpoint of focus, right? And now we are going to see that what is center. So the midpoint C of A dash bisect every chord of the hyperbola that passes through it. What is the meaning of bisect? Means it divides into two equal part, right? And this is called the center of a hyperbola. Means that the midpoint C of A dash. In the figure you can see that C is the midpoint of A dash. So the midpoint C of A dash bisect every chord of the hyperbola that passes through it, right? And this is called the center of the hyperbola, right? So here we have discussed that what is vertices, then we have discussed that what is transverse and conjugate axis, then we have discussed that what is the center of hyperbola. So now we are going to discuss what is a focal chord. So a focal chord is a chord of hyperbola that passes through the focus, right? So what is the focal chord? So a focal chord is a chord of hyperbola that passes through the focus, right? And now we are going to see that what is directrix. So a directrix is a line which is perpendicular to the axis, right? And it is between the center and the vertex, right? So what is directrix? So the directrix is a line which is perpendicular to the axis and it is between the center and the vertex, right? And the equation of directrix is x equals to plus minus a by e, right? So we, in the hyperbola we have a two directrix. So the equation of the first directrix is x equals to a by e. Then we have the second directrix. So the equation of that directrix we have x equals to minus a by e. You can see in the figure. So in the left hand side of the center C, we have a directrix x equals to minus a by e, and in the right side of the C we have another directrix, and the equation of that directrix we have x equals to a by e. So now we are going to discuss that what is double ordinates, right? So if point Q is a point on the hyperbola, then draw Q1, right? Then draw Q1 that is perpendicular to the axis of hyperbola and extend this Q1 until it meets the curve again at Q dash. Then Q dash is called a double ordinates, right? So let's see it again. So point Q if point Q is a point on the hyperbola, right? Then draw Q1 perpendicular to the axis of hyperbola, right? And extend this Q1 until it meets the curve again at Q dash, right? So then we'll say that Q dash is called the double ordinates. So in the figure you can see that we have Q dash, right? So we'll say that Q dash is the double ordinates, right? So now we are going to see that what is latus rectum. So the double ordinates that will passing through the focus is called the latus rectum. So what is latus rectum? So first, latus rectum is double ordinates, right? But there is one more condition. What is the condition? So the condition is that if it is passing through the focus, so we'll say that latus rectum, right? So the latus rectum is double ordinates that is passing through the focus, right? So here we have discussed that what is focal chord, then we have discussed that what is directrix of hyperbola, then we have discussed that what is double ordinates, then we have discussed what is latus rectum of a hyperbola. So now we are going to see some notes. So the first note is that the vertex divides the line the vertex divides the line joining the focus and the intersection point of the directrix internally and externally in the ratio of E ratio 1, right? So that is, if you join the focus and the intersection point of the directrix, right? So then the vertex will divide that line internally and externally in the ratio of E ratio 1, right? So now we are going to see that what is domain and range of a hyperbola x square by a square minus y square by b square equals to 1, or the value of x is less than equals to minus a or greater than equals to a, and the value of y belongs to r, right? So the domain is x is less than equals to minus a or x is greater than equals to a, and the range is y belongs to r. So the line that is passing through both focus of a hyperbola is called a transverse axis, right? So if we have a line that is passing through both focus of a hyperbola, then we'll see that that lines is a transverse axis. So now we are going to discuss the next point. So the line that passing through the center and is perpendicular to the transverse axis in a hyperbola is called the conjugate axis. So what is a conjugate axis? So the line that passes through the center and is perpendicular to the transverse axis in a hyperbola is called the conjugate axis, right? So now we are going to discuss equation of a hyperbola in standard form, right? So let's see that what is that. So if the center of the hyperbola is at origin, means 0 0, and its focus are on the x-axis or y-axis, then that type of equation is called the standard equation of a hyperbola, right? So it means that if the center of the hyperbola is at the origin and its focus are on the x-axis or y-axis, then that type of equation is called the standard equation of a hyperbola, right? So the hyperbola of the form x square by a square minus y square by b square equals to 1. So when the hyperbola is in the given form, so it is also called the equation of auxiliary circle. Means when we have the equation of a hyperbola in the given form x square by a square minus y square by b square equals to 1, then it is also called the equation of auxiliary circle, right? So the center of the hyperbola we have at 0 comma 0, and the focus we have at a comma 0 and minus a comma 0, right? Because we have a two focus at s and s1, right? So the coordinate of s a comma 0 and the coordinate of s1 we have minus a comma 0, right? And the vertices, we have two vertices at a and a1, so a comma 0 and minus a comma 0, right? And what is the directrix? So we will get two directrix, right? So the first directrix is L, and the equation of this we have x equals to a by e, and the second directrix we have L dash, right? And the equation of this line we have x equals to minus a by e, right? And the length of lattice rectum we have L dash. This is the first lattice rectum, and the second lattice rectum we have L dash L1 dash, right? And this is equals to 2b square by a, right? And what is the eccentricity? E equals to we have square root of 1 plus b square by a, right? Or we can write this as b square equals to a square 1 minus e square, right? So in eccentricity we have e equals to square root of 1 plus b square by a square, or we can write this as b square equals to a square times e square minus 1, and the length of the transverse axis is we have 2a, and the length of conjugate axis we have 2b, right? And the equation of transverse axis we have y equals to 0, and the equation of conjugate axis we have x equals to 0, right? And the focal distance of a point on the hyperbola is we have ax plus minus a, right? And the difference of the focal distance of a point on the hyperbola we have 2a. How? Because ex plus a minus ex minus a. So we'll get ex plus a minus ex plus a. So ex will cancel out. So we'll get 2a. Right? So we'll get difference of the focal distance of a point on the hyperbola is 2a. So now we are going to discuss about the what is a conjugate hyperbola. So the equation of the conjugate hyperbola is minus x square by a square plus y square by b square equals to 1. So what is the conjugate hyperbola? So the hyperbola whose transverse and conjugate axes are respectively equals to the conjugate and transverse axis of a given hyperbola. So we'll say that that is the conjugate hyperbola, right? So what is that? So the hyperbola whose transverse and conjugate axes are respectively equals to the conjugate and transverse axis of a given hyperbola. So it is called the conjugate hyperbola of the given hyperbola, right? So if the given hyperbola we have x square by a square minus y square by b square equals to 1, then its conjugate hyperbola will be minus x square by a square plus y square by b square equals to 1, right? So the graph you are seeing is the graph of the conjugate hyperbola. So you can see the graph. So what is the center? So the coordinate of the center we have o is 0 comma 0, and the focus, so we have a two focus, one is at s and another is at s dash. So the coordinate of that 0 comma b and 0 comma minus be we have. So and the vertices we have a, that is 0 comma b, and the second one a1, that is 0 comma minus b. And the directories we have two directories, right? So the first equation of directories we have y equals to b by a, that is given by L, and the second directories we have L dash, and the equation of this we have y equals to minus b by e, right? And what is the length of the lattice rectum? So the length of lattice rectum we have L dash equals to L dash L1 dash. So the length of lattice rectum we have L1 equals to L dash L1 dash equals to 2a square b, right? Now we are going to discuss that what is the eccentricity. So E equals to we have square root of 1 plus a by b ka whole square, or we can write this as a square equals to b square times e square minus 1, right? And what is the length of the transverse axis? So the length of the transverse axis we have 2b, and the length of conjugate axis we have 2a, right? And the equation of transverse axis we have x equals to 0, right? So the equation of transverse axis we have x equals to 0, and the equation of conjugate axis we have y equals to 0. So here we have discussed that like what is vertices of the conjugate hyperbola. Then we have discussed that what is the directories. Then we have discussed that the length of the lattice rectum. Then we have discussed that what is the eccentricity. Then we have discussed that length of the transverse axis. Then we have discussed what will be the length of the conjugate axis. And then we have discussed that equation of a transverse axis. And after that we have discussed that what will be the equation of conjugate axis, right? So now we are going to discuss the focal distance. So the focal distance of a point on the hyperbola is Ey plus minus b, right? And the difference of the focal distance of a point on the hyperbola is 2b. How we'll get 2b? So the difference, so if we'll take the difference of Ey plus minus b, so we'll get Ey plus b minus Ey minus b. So we'll get Ey plus b minus Ey plus b. So Ey will cancel out, so we will get that that is there, the difference is 2b, right? So now we are going to discuss the important notes. So let's see that what is that. So the first point is that if the center of the hyperbola is hk and its axes are parallel to the coordinate axis, then the equation will be x minus h का whole square divided by a square minus y minus k का whole square divided by b square, and this is equals to 1, right? So now we are going to discuss some result on hyperbola. X square by a square minus y square by b square equals to 1. So let's see that what is that. So the first point we have the foci of a hyperbola and its conjugate are on the same circle, right, and together form the vertices of a square. And the second point we have the intersection point of the directrix and the transverse axis are called the foot of the directrix, right? So it means that the intersection point of the directrix and the transverse axis are called the foot of the directrix. Right, and the latest rectum L equals to 2e. So this is the distance between the focus and the foot of its corresponding directrix, right? So the parametric equation of a hyperbola is x equals to a sec theta and y equals to b tan theta, where theta belongs to 0 to 2 pi. And if the position of a point hk is to be checked with respect to hyperbola s, then that point will be either inside or either on the parabola or outside the parabola. If s1 greater than 0, so in that case that point will lie inside the hyperbola, right? If s1 equals to 0, so it means that that point will be on the parabola. If s1 is less than 0, it means that that point is outside the hyperbola, right? So s1 greater than 0 means point is inside the hyperbola, s1 equals to 0 means that the point is on the parabola, and s1 is less than 0, it means that the point is outside the parabola, right? Outside the hyperbola, where we have given the value of s1 equals to x1 square by a square minus y1 square by b square minus 1, right? So you just need to put the value of x1 y1. Right, so now we are going to discuss about the tangent to a hyperbola. So let's see that what is that. So a line that cuts the hyperbola at only one point is called the tangent to the hyperbola, right? So if you can see that point P is touching the hyperbola, right? So that's why we'll say that that line is a tangent to the hyperbola. So now we'll tell you that if you are given a point P and you need the equation of the tangent to the hyperbola at a point x1 y1, then the equation of the tangent will be x times x1 divided by a square minus y times y1 divided by b square equals to 1. And if you want the equation of a line in slope form, that is in the form of slope m, then the equation of tangent will be y equals to mx plus minus square root of a square m square minus b square, right? So if you need to find the equation of the tangent in the parametric form, so that equation we have x by a sec theta minus y by b tan theta equals to 1 at a point a sec theta comma b tan theta, right? So we have discussed the equation of a tangent in point form, in slope form, and also we have discussed the equation of tangent in a parametric form, right? So the next point we have the line y equals to mx plus c touches the hyperbola. What is the condition? The condition is that if and only if c square equals to a square m square minus b square, right? And the point of contact is, we have given the coordinate of the point of contact, that is we have given plus minus a square by m divided by c comma plus minus b square by c, where the value of c is square root of a square m square minus b square, right? So it means that we can say that if the line y equals to mx plus c, so if the line y equals to mx plus c touches the hyperbola, if and only if c square equals to a square m square minus b square and the point of contact is plus minus a square by m divided by c comma plus minus b square by c, where c equals to square root of a square m square minus b square, right? So this is the condition. So now we are going to discuss some result on tangent. So let's see that what is that. So the first we have two tangent can be drawn from a point to a hyperbola, right? So which means that from the single point two distinct tangent lines can be drawn, right? So if you have a curve given by xy equals to c square, right? So then if t1 and t2 are 2 points on this curve, when we draw a tangent line as these 2 points, right? So this tangent will intersect each other somewhere. Therefore the coordinate of the intersecting point will be, what is that? We have given the coordinate, what is that? 2 times c1 times t1 times t2 divided by t1 plus t2 comma 2c divided by t1 plus t2, right? So if you have a curve given by xy equals to c square, right? Then if t1 and t2 are 2 points on this curve xy equals to c square, right? So when we draw a tangent line as the at this 2 point, so in that case this tangent line will intersect each other somewhere, right? So therefore the coordinate of the intersecting point we have, what is the coordinate? So the coordinate is that 2 times c1 times t1 times t2 divided by t1 plus t2 comma 2c divided by t1 plus t2, right? So if you want to find the tangent at a point and you have given a point in the parametric form, so the tangent at the point p, where the coordinate of p we have a sec theta 1 and b tan theta 1, and also we have given another point that is q, and the coordinate of this point we have given a sec theta 2 comma b tan theta 2 intersect at the point. What is the coordinate of that point will be? We will get r, and the coordinate of this point we have a cos theta 1 minus theta 2 divided by 2 whole divided by cos theta 1 plus theta 2, right? Comma b sin theta 1 plus theta 2 divided by 2 whole divided by cos theta 1 plus theta 2, right? So if your points are given in polar form. For example, if you have a given point P and Q, then if we consider their intersection point, so you will get a point R, right? And the coordinate of the point R we have given. So now we are going to discuss the fourth point. So what is the fourth point? So the fourth point we have given that the equation of pair of tangent drawn from an external point P, and we have given the coordinate of P, that is x1 y1, to the hyperbola each s1 equals to t square, where we have given s, that is equals to x square by a square minus y square by b square minus 1, and also we have given s1. What is s1? S1 equals to x1 square divided by a square minus y1 square divided by b square minus 1, and also we have given t. So t equals to, we have given x1 divided by a square minus y1 divided by b square minus 1, right? So the equation of the pair of tangent drawn from an external point P to the hyperbola is s1 equals to t square, right? So here we have given the value of, what is the value of s, what is the value of s1, and what is the value of t we have given. So now we are going to discuss the result on T1. So the next point we have the equation of chord of contact is x1 divided by a square minus y1 divided by b square equals to 1, or we can say that t equals to 0, right? And the next point we have the equation of chord of the hyperbola whose midpoint is x1 y1 is t equals to s1, right? So it means that t equals to s1, it means that x1 divided by a square minus y1 divided by b square equals to x1 square divided by a square minus y1 square divided by b square, right? And the equation of a chord that joins the point a sec alpha comma b tan alpha and a sec beta comma b tan beta is x by a cos alpha minus beta divided by 2 minus y by b sin alpha plus beta divided by 2 equals to cos alpha plus beta divided by 2, right? So here we have discussed 3 more result on tangent. So now we are going to discuss that normal to a hyperbola, right? So what is normal? So a line which is perpendicular to the tangent of a hyperbola is called the normal of the hyperbola, right? So a line which is perpendicular to the tangent of a hyperbola is called the normal of a hyperbola. In this figure you can also see that. So if you find the equation of the normal in point form, then suppose any point x1 y1 is given, then the equation of the normal will be a square x divided by x1 plus b square y divided by y1 equals to a square plus b square, right? So now we'll find the equation of the normal in slope form. So y equals to mx minus plus m times a square plus b square divided by square root of a square minus m square b square, right? And the point of intersection will be plus minus a square divided by square root of a square minus b square m square comma minus plus b square m divided by a square minus b square times m square. And in the parametric form, the equation of a normal we have ax cos theta plus by cot theta equals to a square b square at a point a sec theta comma b tan theta, right? So here we have discussed that what is a normal to a hyperbola, and then we have discussed that equation of a normal, right, in fine form, and then we have discussed in slope form, and then we have discussed in the parametric form. So if the straight line Lx plus My plus n equals to 0 is normal to the hyperbola x square by a square minus y square by b square equals to 1, then we have one condition. What is that? A square by L square minus b square by m square equals to a square plus b square का whole square divided by n square we will get, right? So if the straight line is normal to the hyperbola, then we'll get this condition, right? And second thing is that four normal can be drawn from any point to a hyperbola. Means that from any point four normal can be drawn to the hyperbola. So the line y equals to mx plus c will be a normal to the hyperbola x square by a square minus y square by b square equals to 1 if there is some condition. What is that? This is c square equals to m square times a square plus b square का whole square divided by a square minus b square times m square, right? So if the normal at 4 points, we have given 4 points p q r s. So the coordinate of p we have given x1 y1, then we have given x2 y2, then we have given x3 y3, then we have given x4 y4 on the hyperbola x square by a square minus y square by b square equals to 1 are concurrent, meaning that they are passing through the same point. Then we have this condition x1 plus x2 plus x3 plus x4 times 1 by x1 plus 1 by x2 plus 1 by x3 plus 1 by x4 equals to 4, right? So this is the condition. So if this 4 point on the hyperbola are concurrent, so then we will get this. So now we are going to discuss what is pole and what is polar. So let P be a point, right, which can be inside or outside the hyperbola. So if we draw two tangent lines from a point P to the hyperbola which touch the hyperbola, then the locus of the points of contact of these two tangent lines on the hyperbola with respect to the hyperbola is called the polar of a point P, right? And P is called the pole of that polar, right? So if you take any point P, whether it is inside or outside the hyperbola, and draw two tangent lines from P to the hyperbola, then the locus of the point of contact of this tangent line on the hyperbola is called the polar, right? And P is called the pole of that polar, right? So if we have a given hyperbola x square by a square minus y square by b square equals to 1, and we want to find, and we have given 2 points p equals to x1 y1 and q equals to x2 y2 of a hyperbola, right? So the polar of 2 points p and q of hyperbola are x x1 by a square minus y y1 by b square equals to 1, and the second we have x x2 by a square minus y y2 by b square equals to 1. So the polar of the point P, we have x x1 by a square minus y y1 by y y1 by b square equals to 1, and the polar of the point Q, we have x x2 by a square minus y y2 by b square equals to 1, right? So here we have discussed that what is the pole and polar. So if the polar of the point P passes through Q, then we have x x2 by a square minus y y2 by b square equals to 1, and if the polar of the point Q passes through the point P, then we have x1 x2 by a square minus y1 by 2 by b square equals to 1, right? So now we are going to discuss what is the conjugate points and what is the conjugate's plane. what is the conjugate point and what is the conjugate lines. So two points are called conjugate points of each other with respect to a hyperbola if each point lies on the polar of the other points, right? So therefore if two points are on the polar of each other, then we'll say that they are called conjugate points, right? And what is the conjugate lines? So two lines are called conjugate lines with respect to the hyperbola x square by a square minus y square by b square equals to 1 if each line passes through the pole of the other line, right? So therefore two lines are called conjugate lines when each line passes through the passes through the pole of the other line, right? So so if we have a two lines L1x plus M1y plus N1 equals to 0, and we have second line L2x plus M2y plus N2 equals to 0, or conjugate lines with respect to the hyperbola x square by a square minus y square by b square equals to 1. What is that? So there is one condition. The condition is that a square times L1 times L2 minus b square times M1 times M2 equals to N1 times N2, right? So if this is satisfied, so we'll say that these two lines are conjugate lines with respect to the hyperbola x square by a square minus y square by b square equals to 1. So now we are going to see that what is the director circle. So the locus of a point where tangent lines to the hyperbola x square by a square minus y square by b square equals to 1 intersect each other perpendicularly is called a director circle, right? So we are saying that the locus of the point of intersection of the tangent to the hyperbola x square by a square minus y square by b square equals to 1, which are perpendicular to each other, means that the two tangent are perpendicular to each other, right? So if we take the locus of their intersection point, so that we'll say that that is called a director circle, right? So in this figure you can see that we have a we have drawn two tangent line that are perpendicular to each other, and we have a point P, right, that HK. So if you will take the locus of this point, so we'll get a director circle, and the equation of a director circle is x square plus y square equals to a square minus b square, right? And the circle x square plus y square equals to a square is known the auxiliary circle of both hyperbola, right? So now we are going to discuss what is the asymptote. So as I was saying asymptote, so an asymptote is a straight line that touches the curve at 2 points at infinity, but it is not entirely at infinity itself, right? So you can see the figure of the asymptote we have. Suppose you have given the equation of hyperbola x square by a square minus y square by b square equals to 1. Then you will see two lines. These lines are called asymptote lines, right? So asymptote lines are straight lines that touch the curve at 2 points at infinity, right? So now we are going to discuss some result on asymptote. So the first point is that we have a hyperbola and its conjugate hyperbola have the same asymptote, right? So if we have a hyperbola and if you have a conjugate hyperbola, so these both hyperbola have the same asymptote, right? So if you can find the asymptote of the hyperbola, so you can easily find what will be the asymptote of the conjugate hyperbola because both are the same. and the angle between the asymptote of the hyperbola x square by a square minus y square by b square equals to 1 is 2 tan inverse b by a. And the next point is that asymptote always passes through the center of a hyperbola, right? And the bisector of the angle between the asymptote or the coordinate axis, right? So this is the fourth point. And the last point we have the asymptote of a hyperbola are the diagonals of the rectangle that are formed when we draw lines from the extremities of each axis parallel to the other axis, right? So the asymptote of a hyperbola are the diagonal of the rectangle that are formed when we draw lines from the extremities of each axis parallel to the other axis, right? So now we are going to discuss what is a rectangular or equilateral hyperbola. So so a hyperbola whose asymptotes include a right angle, right, is said to be rectangular hyperbola. Or we can say that if the length of the transverse axis and the conjugate axis of any hyperbola are equal, then it is also called a rectangular hyperbola, right? So there is two definition of a rectangular hyperbola. So the first one is that a hyperbola whose asymptote include a right angle is called a rectangular hyperbola. And the second one we have, if the length of the transverse axis and the conjugate axis of any hyperbola are equal, then we'll say that that hyperbola is a rectangular hyperbola, right? So we have discussed two definitions. So we will see that the two equation of a rectangular hyperbola. So let's see that. So this is the first equation we have. So the rectangular hyperbola of the form x square minus y square equals to a square, right? You can see the figure. So the asymptotes are perpendicular lines, that is x plus minus y equals to 0, right? And the eccentricity in this case we have e equals to root 2 and the center O, that is at 0 comma 0, and the we have two focus S and S dash, right? And the equation of this is plus minus root 2a comma 0, right? And the equation of directrix we have x equals to plus minus a by root 2, and the length of the lattice rectum we have 2a, and if you take the point form, so we'll get that x equals to x1 and y equals to y1, right? So next is the equation of the tangent. So the equation of tangent we have x times x1 minus y times y1 equals to a square, right? So if we have a rectangular hyperbola of the form x square minus y square equals to a square, so the equation of tangent at this hyperbola we have x1 minus y1 equals to a square, right? And the equation of normal we have x1 by x plus y1 by y equals to 2, and the parametric form we have x equals to a sec theta, y equals to a tan theta we have given, and the equation of tangent we have x sec theta minus y tan theta equals to a, right? And the equation of normal we have x by sec theta plus y by tan theta equals to 2a, right? So now we are going to discuss the rectangular hyperbola of the form xy equals to c square, right? So the asymptotes are perpendicular lines, that is x equals to 0 and y equals to 0, and there is eccentricity in this case also we have e equals to root 2 and the center at 0 comma 0, right? And we have focus, we have two focus at x and s dash. So the equation of this is we have root 2c comma root 2c, and the second one we have minus root 2c comma minus root 2c, right? And we have the vertices v1 comma v2. So v1 we have c comma c, and v2 we have minus c comma minus c. And the directrix we have x plus y equals to plus minus root 2c. And the latest rectum we have latest rectum equals to 2 root 2 comma c. And the point form we have x equals to x1 and y equals to y1. And the equation of tangent we have xy1 plus yx1 equals to 2c square, right? So this is equals to xyx1 plus yy1 equals to 2, right? And the equation of normal we have xx1 minus yy1 equals to x1 square minus y1 square. And the parametric form we have x equals to ct and y equals to c by t. And the equation of tangent we have x plus yt square equals to 2ct in the parametric form. And the equation of normal in the parametric form we have t square x minus y equals to c times t cube minus 1 by t, right? So here we have discussed all things about the rectangular hyperbola, that is of the form xy equals to c square. So here we have discussed two types of a rectangular hyperbola, right? So first and the second one. So the second one we have discussed xy equals to c square, right? So now we are going to discuss some question based on the theory which we have discussed. So wait for 5 minutes, students. Wait for 5 minutes. So student, let's see some question on the hyperbola. So this is our disclaimer. So in this we'll solve practice question from 1 to 6. So this is our first question. So in this question we have given that if the vertices of a hyperbola are 0, comma plus minus 6, and also we have given the value of eccentricity, that is 5 by 3. Then we have given two statements. So the first statement we have given the equation of hyperbola is y square by 36 minus x square by 64 equals to 1. And the second statement we have given the foci of hyperbola are 0, comma plus minus 10. Right, so we have given four options, so we need to find that which option is correct. Right, so student, please try to solve this question and then we'll discuss the solution. Right, so everyone please try to solve this question. Everyone please try to solve. Here you have given the vertices and you have given the eccentricity, right? So from here you can easily find what will be the equation of a hyperbola. And if you know the equation of hyperbola, so then we can find that what will be the foci of hyperbola, right? So student, please try to solve. Everyone please try to solve. And if you are facing any difficulty, please write in the comment box so that we can discuss that. Anyone got the answer? Please tell me. Yeah, anyone got the answer? Yeah, okay. Let's discuss the solution. So the answer is both 1 and 2 are true. So let's see that how. So now first we'll see that what is the formula and key points we are going to use in this question. So the first thing is that we know that if the vertex of a hyperbola are on the y-axis, right, then the equation each of the form y square by a square minus x square by b square equals to 1, right? So let's start the solution. Yes, Versa, very good, very good. Yeah. So since the vertices are on the y-axis, so the equation is of the form y square by a square minus x square by b square equals to 1, right? As vertices we have given that is 0 plus minus 6, 0 comma plus minus 6. So we have given the value of a equals to 6, right? And we know that b square equals to a square times e square minus 1. So from here we can easily find what will be the value of b square, right? So the value of b square is 64, right? So we can say that the required equation of the hyperbola is y square by 36 minus x square by 64 equals to 1, and the foci are 0 comma plus minus AE, and we have given the value of A is 6, and also we have given the value of E is 5 by 3, right? So when we'll do 6 times 5 by 3, so we'll get 10, right? So we will get the value of A equals to 10. So that's why we can say that the foci are 0 comma plus minus A. So this implies that 0 comma plus minus 10, right? So now we are going to discuss the next question. So in this question, we need to find that the equation of a hyperbola, and we have given that the length of whose latest rectum is 8, and also we have given eccentricity is 3 by root 5, right? So we have given 4 options, so we need to find that which option is correct. Yeah, everyone please try to solve, and if anyone is facing a difficulty, please write in the comment box so that we can discuss that why you are facing the difficulty. Yeah, everyone please try to solve this question. Yeah, Varsa, please try to solve this question and tell me what you are getting. Yeah, anyone got the answer? Okay, so let's see the solution. So the correct answer is B, means 4x square minus 5y square equals to 100, right? So now we are going to see that how B will be true. So before that, we are going to see that the formula and key points that we will use in this solution. So the equation of a hyperbola is x square by a square minus y square by b square equals to 1, and the latest rectum of a hyperbola is 2b square by a, and the eccentricity of a hyperbola is e square equals to b square by a square plus 1, right? So let's start the solution. So let the equation of a hyperbola be x square by a square minus y square by b square equals to 1. We'll say that this is an equation number 1, right? So we have given the length of the latest rectum, that is equals to 8. We have given in this question, right? So it means that we have given 2b square by a equals to 8. So from here we can write the value of b square equals to 4a, right? And we know that b square equals to a square times e square minus 1, and this is equals to 4a we have. So when we'll simplify this, so we'll get that a times e square minus 1 equals to 4, and we have given the value of eccentricity. It means that we have given the value of e equals to 3 by root 5, so e square will be 9 by 5, right? So here we are just putting the value of e square equals to 9 by 5, so we will get a times 9 by 5 minus 1 equals to 4. So when we'll simplify this, so we'll get the value of a equals to 5, right? So putting a equals to 5 in b square equals to 4a, so we'll get the value of b square equals to 20, right? So hence we can say that the equation of the required hyperbola is x square by 25 minus y square by 20 equals to 1. So now we are going to solve the next question. So in this question, we need to find the eccentricity of a hyperbola x square by a square minus y square by b square equals to 1, which passes through the point 3 comma 0 and 3 root 2 comma 2, and we have given 4 options. So we need to find that which option is correct. So everyone, please try to solve this question. So if you are facing any difficulty in the solution, so you can ask in the chat box, right? So that we can discuss. Vatsa, please try to solve this question. Yeah, everyone, please try to solve this question. Anyone got the answer? Anyone got the answer? Okay, so let's see the solution. So the correct answer is D, that is root 13 by 3. So now we are going to discuss formula and key points that we will use in this solution. So we know that eccentricity E equals to 1 plus b square by a square, right? So let's start the solution. So we have given that the hyperbola x square by a square minus y square by b square equals to 1 is passing through the point 3 comma 0 and 3 root 2 comma 2, right? So from here we get a square equals to 9 because we have given the value of a equals to 3. So that's why we will get the value of a square equals to 9, and we will get the value of b square equals to 4 because we have given b equals to 2. That's why. Again, we know that b square equals to a square times e square minus 1. So we have the value of b square and also we have the value of a square. So we just need to put the value of a square and b square. So we will get 4 equals to 9 times e square minus 1. So from here we will get the value of e square by e square equals to 13 by 9, right? So we'll get the value of e equals to root 30 divided by 3, right? So here we have calculated the value of eccentricity E and we are getting this value equals to root 30 by 3. So anyone has doubt in the solution, you can ask in the chat box. So now we are going to discuss the next question. So in this question, we need to find eccentricity of a hyperbola x square by k plus y square by k square equals to 1, where k is less than 0. So we have given 4 options. So we need to find that which option is correct. So everyone, please try to solve this question. Everyone? Yeah, everyone please try to solve. Anyone got the answer? Like which option is correct? Please. Please tell me in the comment box. Yeah, you can choose your option in the comment box. Okay, so let's see the solution. So the correct answer is D, that is square root of 1 minus 1 by k. So now we are going to see that formula and key point that we will use in this. So the equation of hyperbola is, so y square by a square minus x square by b square equals to 1. So then in this case we have the value of eccentricity e square equals to 1 plus a square by b square. Right, so let's start the solution. So the given equation can be written as y square by k square minus x square by minus k. This is equals to 1. And since we have given that k is less than 0, so that's why we can say that minus k is greater than 0. So on comparing this equation with y square by b square minus x square by a square equals to 1, we will get b square equals to k square, and we'll get a square equals to minus k. Right, so we can write the value of eccentricity E equals to 1 plus minus k by k square. This is equals to 1 minus k by k square, because we are getting the value of b square equals to k square and the value of a square equals to minus k. Right, so if we will simplify this, so we will get the value of e square equals to 1 minus 1 by k. So that's why the value of e equals to square root of 1 minus 1 by k. So now we are going to discuss the next question. So in this question we need to find the equation of a hyperbola whose foci are minus 2 comma 0 and 2 comma 0, and we have given the value of eccentricity, that is 2, right? And also we have given 4 options, so we need to find that which option is correct. So everyone please try to solve this question. Anyone got the answer? Yeah, so please try to solve this question, right? If you are facing any difficulty, you can ask in the comment box, so that we can discuss that why you are facing the difficulty and all these things, right? Yeah, please, everyone please try to solve. Okay, let's start the solution. So the correct answer is C. Yes, yes, Varsa, very good, very good. Yeah, so the correct answer is C, right? So we'll get the equation of the hyperbola is 3x square minus y square equals to 3. So now we are going to discuss formula and key point that we will use in this solution. So the first thing is that general equation of a hyperbola, we know that is x square by a square minus y square by b square equals to 1, and its foci are plus minus a comma 0, and the length between foci is 2ae, right? So let's start the solution. So let equation of a hyperbola be x square by a square minus y square by b square equals to 1, and we have given foci are minus 2 comma 0 and 2 comma 0, right? So in this figure you can see that we have a 2 foci, that is minus 2 comma 0 and one is 2 comma at 2 comma 0. So where 2ae equals to, we have given that is equals to 4, right? And so we have given the value of eccentricity E equals to 2, right? So when we'll solve this, so we'll get the value of a equals to 1. And we know that a square by a square times e square equals to a square plus b square. And we have given the value of a equals to 2. So that's why we'll get the value of a square times e square equals to 4. And also we have given the value of a equals to 1. So we'll get the value of a square is also 1. So when we'll put all this value, so we'll get this equation as 4 equals to 1 plus b square. So from here we'll get the value of b square equals to 3. Right? So here we'll get the value of b square equals to 3. Right? So we can say that the equation of the hyperbola is x square by 1 minus y square by 3 equals to 1, or we can say that 3x square minus y square by 3. So now we are going to discuss the next question. So in this question we need to find the length of the transverse axis of the hyperbola 3x square minus 4y square equals to 32, right? And we have given 4 options, so we need to find that which option is correct. So everyone please try to solve this question. Everyone please try to solve, and please try to respond, right? Okay, let's start the solution. So the correct answer is A, that is 8 root 2 divided by root 3. So now we are going to discuss formula and key point we'll use in the solution. So the equation of the hyperbola, we know that x square by a square minus y square by b square equals to 1, right? And the length of the transverse axis, we know that that is equals to 2a. So let's see the solution. So the equation, the given equation, we can rewrite this as x square by 32 by 3 minus y square by 8 equals to 1. So from here we can rewrite this equation as x square divided by 4 root 2 divided by root 3 का whole square minus y square divided by 2 root 2 का whole square, and this is equals to 1. So now we are going to compare this equation with the standard equation, that is x square by a square minus y square by b square equals to 1. So when we'll compare this equation with the standard equation, so we'll get the value of a square equals to 4 root 2 divided by root 3 का whole square, and the value of b square equals to 2 root 2 का whole square, right? And we know that the length of the transverse axis of a hyperbola is 2a. So this is equals to 2 times we have the value of a, that is 4 root 2 divided by root 3, right? So we will get the length of the transverse axis of a hyperbola is 8 root 2 divided by root 3, right? So thank you for your attention. I hope this session was useful. Hello students, in today's lecture we are going to learn about wave optics and this is theory part second. This is our disclaimer. So in today's lecture we will discuss first amplitude ratio, then Young's double slit experiment, then we will discuss fringe width. After that we will also discuss diffraction and polarization. All right. So our first concept is amplitude ratio. All right. So here question arises, what is amplitude ratio? So before discussing the amplitude ratio, first let's look at the relation between amplitude and intensity. Okay. So we know intensity is directly proportional to the square of amplitude. So this is just a simple mathematical calculation. Okay. So from this relation we can say intensity, under root intensity is directly proportional to amplitude. Okay. So we know the formula for resultant intensity of two waves. Okay. So IR is the resultant intensity, I1 intensity of first wave, whereas I2 is the intensity of the second wave. Okay. So the resultant intensity will be I1 plus I2 plus 2 into under root I1 I2 cos phi. Okay. And phi here, phi is the phase difference. Okay. Now there are two conditions. First, to get maximum intensity. Second, to get minimum intensity. Okay. So if we talk about the maximum intensity, so in case of maximum intensity, phi should be 0. Okay. So when you put the value of phi in the above relation, which relation? In the relation of resultant intensity, you will be get I max, maximum intensity, okay, which is equal to under root I1 plus under root I2 whole square. And let this is equation first. All right. Second is similarly for minimum intensity. For minimum intensity, phi should be pi by 2. Okay. So the intensity equation will become I minimum, it means minimum intensity, is equal to under root I1 minus under root I2 whole square, and let this is equation second. All right. So here we have a two equations. Okay. For maximum intensity and for minimum intensity. All right. Now we will discuss about the amplitude ratio. So when we dividing equation second, this one, with respect to equation first, so we will get I max divided by I minimum, and we know the value of maximum intensity, that is what? Under root I1 plus under root I2 whole square, whereas for minimum intensity we know under root I1 minus under root I2 whole square. Okay. So this is the I max and this is I minimum, ratio of maximum intensity and minimum intensity. Okay. Now we will see how to write this intensity ratio in terms of amplitude ratio. Yes, you can guess from a first relation. So we know intensity is directly proportional to amplitude square. Okay. So from this relation, we can write the amplitude ratio. All right. So we have ratio of maximum intensity or minimum intensity, that is under root I1 plus under root I2 whole square, divided by under root I1 minus under root I2 whole square. Clear? Now for this we will divide both the numerator and denominator by square root of I2. So it will be I max upon I minimum equal to I max divided by I minimum will be equal to square root of I1 divided by square root of I2, okay, plus 1 whole square divided by square root of I1 divided by square root of I2 minus 1, okay, whole square, this one. So this is a simple mathematic calculation. So this is the ratio. Here square root of I1 to I2 will be our amplitude ratio, okay. So this expression will be further modified. So I max divided by I minimum will be equal to A1 upon A2 plus 1 divided by A1 upon A2 minus 1 whole square, okay. So this term A1 divided by A2 here, A1 divided by A2 here is our amplitude ratio, yes or no? So we can write this equation as I max upon I minimum is equal to R1 R plus 1 divided by R minus 1, okay. So here we know what is R. R is A1 upon A2. So it become A1 upon A2. So we can say R plus 1 upon R minus 1 whole square. Clear? So here R is what? A1 upon A2 equal to amplitude ratio, which is equal to R. We know A1 is what? A1 is the amplitude of intensity first. A1 is the amplitude of intensity second. So R equal to A1 upon A2 amplitude ratio. Clear? Any doubt here? Yes or no? This is all about the amplitude ratio. And students, this concept is very important for the exam, because sometimes question ask from this concept I max upon I minimum in the form of R. Alright. So we can say I max upon I minimum equal to R1 plus R2, R1 plus 1 divided by R minus 1 whole square. Alright. Whole square. Next we will study about Young's double slit experiment. Okay. So British physicist Thomas Young used a very clever technique to lock the phases of waves that is emanating from S1 and S2. Okay. So what is here S1 and S2? Here, look at here in the diagram. Here S is a given source. Okay. S is what? S is a given source, which is denoted by capital S. And this source, this S source generates waves. Okay. These waves are emanating from source S1 and S2. From source S1 and S2. Okay. Young made two pinholes, okay, which are shown here S1 and S2. Both these pinholes are very close to each other. It means what? The distance between these two holes are very small. Okay. And they are made on an opaque screen. All right. This is an opaque screen. This distance between the distance between the screen and the source is S1 and S2 is capital D, denoted by capital D. Look at here, this one. Okay, as shown in the figure. So as source S1 S2 is the 2-point pinholes generated by source S. Now, so here look at here in this diagram. So there is a source S, source S, from which spherical waves are emanating. Okay, spherical waves. These are the spherical waves. From this source S, spherical waves are emanating. Okay. Further ahead, there are two slits, S1 and S2, from which secondary spherical waves are emanating. So this is S1 and S2, and from S1 and S2, secondary waves. These are the secondary waves. Secondary waves are emanating. Okay. Then these two will act as a coherent sources. Which one? S1 and S2. S1 and S2 acts as a coherent sources. Why? Why act as coherent sources? Think about it. Because both sources, S1 and S2, both sources uh, originate from a single source S. Okay, single source S. Alright. So a screen is placed in front of, like this, in front. Now this source, which is denoted by S, is spreading waves in this manner. Okay. Uh, Coming out from S1 and S2. These secondary wavelets, these emanating from S1 and S2 will produce the alternate dark and uh, bright pattern as shown on the screen. Look at like this. Okay, and called as the interference pattern. Whether the fringes will be dark or bright will depend on the path difference at a point on the screen. All right. So these are the dark and bright fringes on the screen. Okay. So here B naught, or we can say V0, is a central fringe. All right. So the spherical waves emanating from S1 and S2 will produce interference fringes on the screen. We can say GG prime. All right. So in this setup, listen carefully. Alternate dark and bright fringes are formed on the screen. Okay. So here, for all the waves reaching from S1 and S2, the path difference between them will be 0. Okay. So we will get a bright fringe here. We will get a bright fringe here, which is called the central bright fringe. So this B naught that is visible, this is our central bright fringe. Okay. Now consider any other point on the screen as a P. Look at here, as a P. So light waves reaching point P have their sources S1 and S2. Okay. So the waves coming from point coming to point P. Okay, coming to point P from these two light sources S1 and S2. These two light sources S1 and S2, situated at a distance x. Situated at a distance x from the origin, or we can say that it is a distance x from the central point. Okay. So path difference is denoted by delta. Clear? And one important point here. So from this illustration, we can say the distance between sources S1 and S2 is small d, and distance between sources and screen is capital D, and from origin to point P is x. Okay. So there are three most important symbols: small d, capital D, and x. All right.
So to calculate the path difference, okay, S2, this is the longest part, S2P, yes or no? S2P is the longest path and S1P is the smallest part, uh, smaller part, yes or no? So as we see here, we can say S2P, to get the difference, okay, to S2P minus S1P is equal to what? It will be XD divided by capital D, okay. This XD divided by capital D is the what? It is the path difference, okay. Think about it, one situation, suppose this point P situated at O, okay, situated at O. In that case, what will be the S2P minus S1P? Give me answer. In that case, what will be the S2P minus S1P? Yes, anyone? What will be the, in that case, what will be the path difference delta? Yes, Varsha, Karthik, VK. What will be the path difference? Yes, 0. Okay. Why 0? Because the distance between S1, point S1 and origin, and the distance between S2 and origin will be equal. So S2P minus S1P will be what? 0 na? So we can say delta equal to 0. So in that case, when uh, point P lie at the origin, okay, at O, so we can say in that case path difference will be 0. Okay. Now here we will discuss some cases for fringes, okay, like dark fringe, like bright fringe, central fringe, okay. So the first case is the condition for bright fringes. Clear? If xd divided by capital D is equal to n lambda, this one xd divided by capital D equal to n lambda, then we get nth bright fringe, okay. So from this equation, position of the bright fringes on the screen are given by the relation. So to get the position, you have a formula n into capital D into lambda divided by small d, okay. So this is important. Why? Because this helps us to calculate the position of bright fringes on the screen. If we talk about the case second, okay, to calculate the nth dark fringe, okay, so it will be if xd divided by capital D is equal to 2n minus 1 into lambda by 2, then we get nth dark fringe, okay. So to calculate the position of nth dark fringe on the screen, okay, and the relation is x is equal to 2n minus 1 into d into lambda divided by 2d, okay. So there is a two positions, listen carefully, there is a two positions, first for the bright fringe on the screen, second for dark fringe on the screen, where n is what? N is equal to 1, 2, 3 and 4. So here uh, this is we can say this is very important. Clear? Any doubt here? Yes or no? All right. Now next concept is fringe width. What is fringe width? We can say fringe width is a like distance between two consecutive bright or dark fringes is called fringe width. Okay, and it is denoted by beta. Okay, so this is the symbol of beta. So to calculate the fringe width, that is distance between two consecutive bright and dark fringes, we have a formula, that is beta equal to capital D into lambda divided by small d. Okay, and we know what is small d. Small d is the distance between what? Sources. Yes, as distance between S1 and S2. Okay, so look at here, you can see the fringe width. Okay, this is the distance between two consecutive bright and dark fringes. Here capital D is the distance from the source and to the screen, source to screen. Okay, and lambda is the wavelength and small d is the distance between the sources. So in the given arrangement, the fringes formed will have a constant fringe width, which is also clear from the expression, meaning all fringes are uniformly spaced. It means what? Look at bright fringe, okay, dark fringe, then bright fringe, dark fringe, okay. And from this illustration, we can say the distance between two consecutive bright and dark fringes is called fringe width beta. Beside this, the fringe width beta is, this is important, so listen carefully. Beta is directly proportional to capital D. Beta is directly proportional to lambda, which is called wavelength. Then beta is inversely proportional to small d, which is the distance between the two sources. Okay. Thank you for your attention. Now students, we will discuss a more important concept, diffraction. Then we will discuss uh, polarization. After that, we will solve some practice questions, okay, based on wave optics. All right, please wait 2 minutes. Students, here phi should be pi. Okay, this is a typo error. This, all right. Phi should be pi. Clear? Now we will discuss diffraction. Okay, clear? So what is diffraction? Tell me. So basically, diffraction is a phenomena in which waves, yes, bend, spread or deviate from their uh, straight line path when they passes through a narrow opening or around an obstacle. Okay, whose size is comparable to the wavelength of the wave. So look at here in the figure here. So look at here. Here from source S, lights are coming. Okay, and this is a very narrow slit. Okay, this is a narrow slit, and when light deviates in a deviates, or we can say band in different direction. Okay, so in that case, this is a monochromatic light. Okay, illuminated by a monochromatic source. Okay, so the path will be changed. Okay, light passes through a very narrow slit, it spreads out instead or forming a sharp shadow. All right, look at here. So here this is the geometry of the path differences for diffraction by a single slit. Okay, single slit to slit plane meets on the screen at C. So here in case of diffraction, we want to intensity at any point. Okay, so let's see here, that point is to be P point. All right, so as before, straight lines passing straight lines joining to the different points, that is L, M, N, etc., can be treated as a parallel, making an angle theta with the normal MC. Okay, MC is this one. Look at here, M, this is making angle theta, this MC. All right, so here the basic idea is to divide the slit into much smaller parts and add their contributions at point P with proper phase differences. So we treating different parts of wavefront at a single at a slit as a secondary source. Okay, why? Because the incoming wavefronts is parallel to the plane of the slit and sources are in phase. So from this experiment, it is observed that the intensity has a central maximum at theta equal to 0 degree, and secondary maxima theta should be n plus 1 by 2 divided by into lambda divided by a, which is on becoming weaker and weaker on screen n. All right, so the minima are at this one 0 theta equal to n lambda divided by a, where n equal to plus minus 1 by 2 plus minus 1 plus and plus minus 2 and plus minus 3. So the photograph and intensity pattern corresponding to shown in figure 10.15. Look at here, looks like this. Okay, so No one has ever been able to define the diffraction between interference and diffraction satisfactorily. It is just a question of uses and no specific important physical difference between them. So best we can do is, roughly speaking, it is say that when there are only a few sources, so say two interfering sources, then the result is usually called interference. But if there is a large number of them, that seems that word diffraction more often used. Okay, whereas if we talk about the diffraction polarization, so we can say in polarization, uh, look at here, so this is looks like polarization. So what is polarization? Anyone? What is polarization? Yes. So we can say here, look at here, this is a curves that represent displacement of a string, okay, at different times. All right. So if we talk about the polarization, so we can say polarization is the phenomena in which vibrations of a transverse wave like light are restricted, okay, to we can say to one particular direction or plane, all right, perpendicular to the direction of propagation. So here, so look at figure 10.18, this one. We know light waves are transverse in nature. It means electric field and magnetic field and direction of propagation is both are all are perpendicular to each other, okay, and this can easily demonstrating using a simple polaroid, okay. You must have seen the thin plastic like sheets which are called polarides, okay. So basically here the most important term is to understand the formula of intensity, okay, that is I equal to I naught cos square theta, where I naught is the intensity of polarized light after passing through uh, passing through P1, and this is known as Moll's law, okay. The above expression I is equal to I naught cos square theta shows that the intensity coming out of a single polaroid is the half of the incident intensity, okay. So this one I is equal to I naught cos square theta is most important. Clear? Now we will discuss some uh, important questions based on wave optics. Hello students. Now we will discuss some practice questions based on wave optics. Okay, and this is part 2. This is our disclaimer. So here we will solve some practice questions based on uh, wave optics. So first question, or we can say sixth question. In Young's double slit experiment, the intensity at a point where the path difference is lambda by 6, lambda being the wavelength of the light used, is I. If I naught denotes the maximum intensity, so I upon I naught is equal to what? So in this question, uh, Young's double slit experiment in phenomena is used. Okay, so given options, option A 1 upon root 1 upon under root 2, option B root 3 by 2, option C 1 by 2, and option D 3 by 4. So you have to find out the maximum intensity. Okay, I upon I naught is equal to what? I naught denotes the maximum intensity. Okay, you have to find out the I upon I max. Clear? So this is the question. Please solve this question. You have some time. All right, please solve. Which one is correct? Using the given information, you have to find out the I upon I naught. All right. Which one is correct? Anyone? All right. So the correct option will be option D, 3 by 4. Let's solve this question. So first, to solve this question, uh, we need to find the phase difference. Okay, what is phase difference? You know. So after calculating the path difference, you have to calculate the uh, after calculating the phase difference, you have to calculating the path difference. Okay. So the formula to calculate the phase difference phi, so it will be 2 pi divided by lambda into delta p. All right. So we know the value of delta p. Path difference is given as lambda by 6. So we will use this into our formula. Okay. Then after calculating phi, it will be what? Pi by 3. So 2 pi divided by lambda into pi by 6. So lambda cancel out. Okay, and the 2 1 ja 2, 2 3 ja 6. So remaining term is pi by 3. In Young's double slit experiment, the intensity I at any point on the screen can be expressed as this one. This is the intensity formula in case of Young's double slit experiment. Okay, that is I equal to I max cos square phi by 2. So here in this question we have to find out the I upon I naught. Okay, I naught is the maximum intensity. So I upon I naught is what? I upon I max. Okay, so it will be what? I upon I max is equal to cos square phi by 2. So, and we know the value of phi, that is we already calculated in this one, phi equal to pi by 3. Yes or no? So just put the value of phi in this expression, you will be get I upon I naught. So it will be I upon I naught is equal to cos square pi by 6. So cos pi by 6 is what? Root 3 by 2. And cos square pi by 6 is what? 3 by 4. So I upon I naught is equal to 3 by 4. Okay. So this is our correct answer. Any doubt here? Yes or no? Clear? All right. Next question. In Young's double slit experiment, the intensity at a point is 1 by 4 of the maximum intensity. Okay. Suppose the maximum intensity is I. Okay. So in case in intensity at any given point, it will be what? I by 4. Okay. And the angular position of this point is what? So in this question you have to find out the angular position. Okay. Given options: option A sine inverse lambda by d, option B sine inverse lambda by 2d, option C sine inverse lambda by 3d, option D sine inverse lambda by 4d. So which option is correct? Option A, option B, option C, or option D? And this question asked in AIEEE 2005. So in this question you have to find out the angular position. So please solve this question and find out the correct answer. Clear? Please solve, you have some time, and find out the correct answer. Which one is correct? Angular deviation. You have to find out the angular deviation. Please solve this question. Which one is correct? Anyone? A. So the correct option will be option C, sine inverse lambda by 3d. Let's solve this. So we know that in Young's double slit experiment, the intensity relation I equal to I max cos square phi by 2. Okay, where phi is the phase difference, and this relation is very important. Now according to question, at the point where we need to find the angular position, the intensity is I max by I4. Okay, so we will put this into this equation. Okay, So it will be I max upon 4 is equal to I max cos square phi by 2. Clear? Now we have to find out the phi. So I max upon I max cancel out, and the remaining term will be cos phi upon 2 is equal to 1 by 4. Okay. So we can say phi by 2 equal to pi by 3. Yes or no? It means pi is what? Pi will be 2 pi by 3. Clear? Since we have the relation between phase difference and part difference. So phi equal to 2 pi divided by lambda into delta x, and let this is equation first, where delta x is what? Delta x is d sine theta. Okay. So substituting in equation first, we get sine theta equal to lambda divided by 3d. So theta will be what? Theta equal to sine inverse lambda divided by 3d. This is the angular position. Alright. Next question. The first diffraction minimum due to single slit diffraction is theta. For a light of wavelength 5000 angstrom, if the width of slit is 1 into 10 to the power minus 4 centimeter, then the value of theta is what? So in this question you have to find out the value of theta. Okay. Given options: option A 30 degree, option B 45 degree, option C 60 degree, and option D 15 degree. So which one is correct? Please solve this question and find out the correct option. Alright, please solve. Which one is correct? Yes, Karthik, Varsha, VK. Anyone? Which one is correct? Yes. Which one is correct? Anyone? So the correct option will be option C. Clear? Let's see the solution. So, in a single slit diffraction pattern, the position of the nth minimum is given by the relation, that is d sine theta is equal to n lambda, where d is the single slit width and theta is the angular position of the nth minimum. Okay. For the first minima, we will take the value of n as 1. So, sine theta equal to lambda divided by small d. We will put the given values of wavelength and slit width. Then we will get sine theta equal to 5000 into 10 to the power minus 10 divided by 10 to the power minus 2 into 10 to the power minus 4. So solving this, we will get sine theta equal to 0.5. So from this relation, we have to find out the value of theta. So what will be the value of theta? Yes, anyone? So theta equal to 30 degree. Okay. Next question. A parallel monochromatic beam of light is incident normally on a narrow slit. A diffraction pattern is formed on a screen placed perpendicular to the direction of incident beam. At the first maximum of the diffraction pattern, the phase difference between the rays coming from the edges of the slit is what? So here you have to find out the what? Phase difference. Okay. So given options: option A 0, option B pi by 2, option C pi, and option D 2 pi. So which one is correct? Please solve this question and find out the correct answer. Yes, anyone? Please solve. Please solve this question and find out the phase difference between the rays coming from the edges of the slit. Okay. Yes, find out the correct one. Which option is correct? A, B? Okay. Anyone? So the correct option will be option D, 2 pi. Clear? Let's see the solution. So we know the formula to calculate the path difference between the rays that is coming from the edges of the slit, that is delta P equal to D sine theta. Okay. Phase difference phi is related to the path difference D. Okay. And that is relation is phi d sine theta. Phase difference phi is related to the path difference d sine theta. Okay. So the formula is phi equal to 2 pi divided by lambda into d sine theta. Clear? So this is the formula of phase difference. where d is what? D is our slit width. The first minima for n equal to 1 in the diffraction pattern is d sin theta equal to n lambda, which means sin theta equal to lambda by d. So we will put the value of sin theta into phase difference equation, then we will get phi equal to 2 pi divided by lambda into d into lambda by d. Okay, so lambda d did cancel out, lambda lambda cancel out, the remaining term we can say we get the phase difference as 2 pi. Clear? Yes or no? Any doubt? All right. Next question. In Fraunhofer diffraction experiment, at a single slit using a light of wavelength 400 nanometer, the first minimum is formed at an angle 30 degree. The direction theta of the first secondary maximum is given by what? So given options: option A sine inverse 2 by 3, option B sine inverse 3 by 4, option C sine inverse 1 by 4, and option D tan inverse 2 by 3. So which option is correct? Option A, option B, option C, or option D? You have to find out the correct one. Alright. So please solve this question. You have some time. Please solve. Which one is correct? Wavelength is given, okay? 400 nanometer. Which one is correct? Yes. Karthik, Varsha, VK. Which one is correct? Anyone? Okay. So the correct option will be sine inverse 3 by 4. Let's see its solution. So we know that for the first diffraction, the relation is d sine theta equal to lambda. So d equal to lambda divided by sine theta. So from here we will get the slit width. So we can say for the secondary maxima we have relation d sine theta prime equal to n plus 1 by 2 into lambda. So for first secondary maxima n equal to 1. Okay. So it will be d sine theta prime equal to 3 lambda divided by 2. So when we rearrange it, we will get sine theta prime equal to 3 lambda divided by 2 into 1 by d. Alright. So just put the values. It will be sine theta prime equal to 3 lambda divided by 2 into sine theta divided by lambda. Okay. So in this equation, the value of theta is given, that is 30 degrees. So we will substitute it and solve. So you will be get sine theta prime equal to 3 by 2 into sine 30 degrees. When we solving this, you will get 3 by 4. It means theta prime equal to what? Sine inverse 3 by 4. Okay. So thank you for your attention. Thank you for your attention. That's all for the today. Now we will solve DPP questions. Okay. Yes or no? All right. So please wait 2 minutes. Now we will solve DPP questions. Okay. So there is a 10 questions and you have to solve all. Okay. So let's see first question. So in this question, x1 equal to 12 sine 484 pi t minus 7 pi x, and x2 equal to Okay. So our first question is, calculate the amplitude of unpolarized light incident on the polarizer if the amplitude of transmitted polarized light through it is a by 2. Okay. So in this question you have to find out the amplitude of transmitted light. Okay. So which option is correct? A, B, first, second, third and fourth. You have to find out the amplitude of transmitted polarized light. Clear? So the formula to calculate this, we know IT is equal to, this is the intensity of transmitted polarized light. It will be equal to 1 by 2. This one is I naught. Okay. So using this concept, please solve this question. So here we know if the amplitude of transmitted polarized light is given, that is A by 2. So just put the value here. And we know I is what? I is directly proportional to? I is directly proportional to? Yes, you are right. A square. Okay. So it will be what? It will be I. Okay. I, we can say A by 2. A by 2. A by 2 divided by 2. A by 2 whole square is equal to 1 by 2 A naught square. Okay. A naught square. So when we solving it, you will be get A square by 4 is equal to 1 by 2 A naught square. So here you have to find out the A naught. So what will be the A naught? A naught is equal to A divided by root 2. Okay. So which one is correct? I think this one. Let's see next question. Next question. Unpolarized light falls on two polarizing sheets placed on top of other. What must be the angle between the characteristic directions of the sheets if the intensity of the final transmitted light is 1/3 of maximum intensity of the first transmitted beam? Alright. So here you have to find out the what must be the angle between the characteristic direction of sheets. Clear? So which one is correct? You know the formula in case of polarization, I is equal to what? I naught. Yes or no? I naught cos square theta. So using this formula, please solve this question. Alright. So here question says the 1/3 of maximum intensity. Okay, what is the maximum intensity? I naught. And 1/3 means I will be what? I will be become 1/3 of maximum. It will be I naught by 3. Okay, so it become when we rearrange it will be like I naught by 3 is equal to cos square theta. Yes or no? This one I naught by 3, I naught cos square by theta. Alright. So I naught cancel out. The remaining term 1 by 3 is equal to cos square theta. Yes or no? So taking square root both side, it will be we can say cos theta is equal to 1 by root 3. So 1 by root 3 means what? So we can say theta equal to cos inverse 1 divided by root 3. So which one is correct from this relation? 1 divided by root 3, this one. So I think second one. Okay. Clear? Next question. Two equally illuminated points which are at a distance of 6 into 10 to the power minus 5 centimeter are to be resolved with the help of a microscope If the wavelength of light is used is 546 nanometer, then calculate the numerical aperture. Okay, so which option is correct? You have to find out the numerical aperture. So we know the formula D equal to 1.22 lambda divided by 2 into numerical aperture. Yes or no? So numerical aperture will be equal to what? 1.22 lambda divided by what? D into 2. So just put the value, you will be get Na. Okay. So when we solving this term, after putting the value, you will be get value of Na. So anyone? Which one? Okay. Last one. All right. So it will be 0.5. Clear? So last one, save and next. Next question. A polarized light of intensity I naught is passed through another polarizer whose pass axis make an angle of 60 degree with the pass axis of the former. So what is the intensity of emerging polarized light from second polarizer? So in this question you have to find out the intensity. So you know the formula of intensity in case of polarization? Yes or no? We already discussed. So I is equal to I naught. Yes, you are right. Cos square theta. Okay. So here it is cos 60 degree. So we know cos 60 is what? Yes, 1 by 2. So just substitute the value, you will be get I equal to, yes, I naught 1 by 2 square. So it will be I naught by 4. I naught by 4. I equal to I naught by 4. So which one is correct? D option. Okay. Any doubt? All right. Next one. Angular spread of the central maxima in a single slit diffraction if light wavelength lambda is incident on a slit of width A and the screen is kept at a distance D. So angular spread. So in this question you have to find out the theta. Yes or no? So what will be the theta? 2 lambda by A. All right. Save and next. Let's see next question. So here a small aperture is illuminated with parallel beam of light wavelength lambda equal to 942 nanometer. If the first minima is formed at an angle of position of 1.5 degree, then size of aperture is what? So in this question you have to find out the size of aperture. So we know the formula d sine theta is equal to n lambda. Okay. So using this concept, find out the answer. Clear? Which one is correct? Anyone? Which one? Second? First? Second? Okay. Next one. A beam of unpolarized light of intensity I naught is passed through a polarized A and then through the another polarized B. What is the oriented? So its principal plane makes an angle of 45 degree relative to that of A. The intensity of the emergent light is what? So in this question you have to find out the intensity of emergent light. All right. Please solve. Okay. Which one is correct? Anyone? Varsha, Karthik, VK? Which one is correct? B option. Good. B option. Okay. Good, Varsha. Next question. So let's see next question. We have 7 minutes. Let's see next question. According to Molle's law, if the angle between the pass axis of the polarites is 60 degree, the intensity of incident light is I naught, then intensity transmitted by the second polarite is what? Okay, so in this question you have to find out the intensity. Please solve. So use the formula of intensity and find out the answer. What will be the solution? Anyone? Yes. Good, good, good. First or last? Last. Okay. Varsha? Karthik? VK? Anyone? Rohit? Piyush? All right. So this one. Next question. In the experiment with two crossed polarites P1 and P3, a third polarite P2 is placed between them at an angle theta. The maximum transmitted intensity occurs when theta is what? So here you have to find out the theta. Please solve this question. You have to find out the theta, okay? Yes or no? So to solve this question, you have to apply Molle's law. Okay? Please solve. This one. Let's see next question. Why do the diffraction fringes appear colored when viewed without a filter? This is the theoretical question. Find out the answer. Yes. Because the position of the fringes depends on the wavelength of light. Clear? Now save and submit. So this is our correct answers. Okay, our solutions. Clear? Any doubt here? All right. So that's all for the today. Thank you for your attention, everyone. If you have any doubt, please ask. All right. Thank you.